Hello, wonderful, beautiful people. I want to talk about arrays in C Sharp, and I'm following this course for a certificate. And basically, if we look here, it's in the free code camp, and you can get it completely free. It's from Microsoft, and it's called Foundational C Sharp with Microsoft. You have to basically free code camps work together with the Microsoft learning area, and you have to go through all these steps, and every step after completion, there are like 6 modules who all have a whole bunch of other steps you have to go through, and one of those things is the for each. Here you say 3 of 7. This is one of the modules that you have to do. And if you have all of them, you can get a certificate that you and for Foundational C with Microsoft. Since I've been working with many programming languages, and as actually one of the when I want to get I used to work on the Amiga with lots of basic languages, and like Amos and Blitz Basic, and then I went to on the PC I went with Visual Basic, so I started making actually programs with Visual Basic. But then I thought, well, I never heard people talking that, and this was like 30 years ago. And I never heard people talking about serious applications being written with Visual Basic at that point that much. Maybe now it's more common, I don't know. But C was the programming languages at that point, and I learned C. Now C, of course, is not object oriented; it's sequential. And I found out with Visual. Maybe I learned it before Visual Basic. Actually, I don't know. But I worked with Visual Basic, and I started thinking, well, why not work with C++? Because it was much like Visual Basic, where you could just make up windows in the editor and work with that. The whole visual thing was really cool right then, and so I stepped into C++. I got a job with that. I did that for a while. Then I got a bit bored with all the Windows, you know, all the gray Windows all the time. So and the whole internet was calling me, and I thought, well, if I make websites, I can be more creative. So my creative part, I'm very creative and also like very logical. So the both of them combined very well with doing websites. Now, to be honest, now I realize that I could have just stayed with C++, and that would have been a nice career just doing that. I didn't need to learn that. But yeah, I mean, that's boredom. I just want to challenge myself and learn new things. And I like learning a lot. And I thought, well, the more I learn, the more the better I will get at programming, the more things I can do. And then, of course, when you get into building websites, it's not just HTML, it's not even just CSS or JavaScript. And even nowadays, there's so much stuff that you can use to build a website. So much technologies around just the basics, and even the basics are a lot of different languages and systems that you have to know. So I could just stick with C++, but anyway. And then we had Java, and Java was of course a different version of an improvement on C++, kind of the basic object-oriented programming. And then Microsoft made their version, C Sharp, which is basically the same as Java. So it was very easy for me to do Java, because I realized, well, it's just an upgrade from C++. So I only need to learn a few differences and new improvements and a new system. And then C Sharp, I realized that I could also do C Sharp, because I knew, of course, C++ and C Sharp. And then I did like Yeah, lately, some years ago, Unity was getting really good at making nice, beautiful games, and that was in C sharp. So yeah, that was really great because already was pretty easy for me to get into C sharp, and work with that. So I made some games with C sharp, and I'm working on one now. Right now, it's like called Supernova. It's like a space adventure game, or I think I'm going to turn it into a space survival game, but we'll see. And I have so many ideas. Could be an MMO, could be it could be like just exploration, trading, all the stuff. But yeah, I digress. Um, uh, and also, it will be good to well, getting this foundational C sharp with Microsoft is nice to have the certificate. It's good to when I go for job interviews, so I can show them actually my code and then have some clean code. I mean, you can do it's important like the solid principles where you make sure that your variables are very recognizable. Your code is easy to read for other people that you work with, and all that kind of stuff. And when I made my Supernova game at first, I worked like all day long, like 14 hours a day on it for like a month, like every day in the week, and until yeah, and I got a lot of the stuff working. It's like a almost completely work. Yeah, it's pretty much a completely working game where all the parts are there. You can shoot stuff, you can have pickups, you have enemies, you have an whole environment to go through, different levels. But the thing is that when I showed my code on an interview, I realized it was just the code I've written was like for like proof of concept. You know, I just did it to get things done. I never got to the point where I was refactoring it and making the code easier or better or whatever. I just want to get things done quick and easy. Now that's cool when you just want to get a proof of concept. If you just want to see, well, I want to get something there. But as soon as other people are involved, you want your code to be readable and accessible. So, and the good thing is, although I know all these programming languages and have all this background, going through this foundational C with Microsoft, which I have to do to get that certificate, also, yeah, makes me look at some things again, and I love just going through. I used to do it all the time, like just go through the books, and that's why I love learning new programming languages to just go through the basics again. Make me pick up on a few things I missed or didn't, you know, just I didn't understand fully, you know, and or just get it more in my system, get it more ingrained in my the way I think. I love to really understand stuff and be really good at what I do. So going through everything, it's not. It takes a lot of time, and of course, I know these things like very well already. You know, it's not like I never used to for each statement or something, but you know, because I learn a lot of languages. Sometimes, yeah, I have all these different for each statements in my head for different languages. So focusing on C sharp a bit right now, it's good to like solidify that more. Okay, so that was a very big intro. I'm sorry, but let's go into this. So this is one. This is 3 of 7, and it's of yeah, this thing here. It's one of the parts of I think it's called this. Yeah. So it's one of the parts that you need to learn to get certificate. Um, okay. Suppose you work for a manufacturing company. The company needs you to complete the inventory of your warehouse to determine the number of products that are ready to ship. In addition to the total number of finished products, you need to report the number of finished products stored in each individual bin in your warehouse along with a running total. This running total will be used to create an audit trail so you can double check your work and identify shrinkage. That's people stealing and losing and breaking stuff. Looping through an array using foreach. The foreach statement provides a simple, clean way to iterate through the elements of an array. The foreach statement processes array elements in increasing index order, starting with index 0 and ending with index length -1. It uses a temporary variable to hold the value of the array element associated with the current iteration. Each iteration will run the code block that is located below the for each declaration. So if we look at the code here, here is where the array is created. Then here we have like a loop. So within these brackets, everything what's in between this will be looped. And this is how it is being looped for each statement, and this is what's happening. So there are 3 names. There could have been like a million, but there are 3 names in this in the array, which is called names that you create here. So here again you see at the end you see in names. So in this array, now what's in the array? Rowena, Robin, and Beo. So it goes through for the first one, of course, that's 0. It always starts at 0 in programming. So it goes for the first one, and that this is 0, this is 1, Robin is 1, and Beo is 2. So although there are 3, it goes from 0, 1, 2, 0, 1, 2. Now the first one, you don't need to really use these numbers in this system, because the for each just starts at the beginning and it goes until the end, like it says here. It starts with index 0, so they all have an index, and it ends with index length 1 minus 1. Now that doesn't really exist, so I think it just there's nothing there. So it uses and then uses a temporary variable. So here you see string name. Now that's a name is being declared as a string here. So that's a new variable that you create here just to store those values in. So first you start Rowena in it, then Robin, and then Bao. But so the first time you store Rowena in it, the first loop, you say console write line. Now at that point in name it is Rowena, so it prints that out. Then it goes back to the front, and again it does the same thing, but now it is not at 0 anymore. Now it's at 1. So it takes Robin. So Robin from names is going to be put in name. Now name is has the string Robin in it. Then you get to do again console write line. Now name, we know now it's Robin, so Robin will be print, and then it goes for another. Again the same things happened. It looks for the second one in names, put that in name. Now that's Beo, so Beo is in name. Here when you print that variable that you just used to store stuff in, it will do the last one, which is Beo at index 2. It will be printed, and then it will go to -1. Now -1, there's nothing at -1, so it just ends, right? I think the index length minus, I'm just saying it wrong. Index length -1. Yeah, it's not going to -1. It's not index -1. It's index length -1. I'm sorry. That was like I look really quick through the code and stuff. Sometimes you then you misread it. So so the length. So what is length? Now in the earlier that was explained, but let me start with like the declaration here. So well, I can do that. Let's do length first. So if you would write like names is the array, right? Now what's the length of names? Well, that's the number of things in it. So you put 3 things in it, so the length is 3. So it's 1, 2, 3. Now so the length actually counts from 1 to 3. It doesn't start with 0, because 0 is like nothing, right? So 1 is like 1 apple, 2 apple, 3 apple. You don't have 0 apple. So so you don't have 0 name. 0 names doesn't exist. 0 variable. 0. There will be that's so. Length is 1, 2, 3, so you will have 3 length of 3 for this. But we know that the index actually is 1 less, because you start at 0. So you fix that by saying length, which is 3, minus 1, you know, because there's a difference between counting things and the index that starts at 0. So you fix that difference by going -1, and then you get to the actual index number, and that is 2, because 3 doesn't exist. That would be the fourth actually. So you end up the third item is actually index 2, and so you just do length minus 1. Okay, so and that all happens internally in this for each thing. So you don't have, you could program that, and you can probably iterate the length, use the length to go and do that, all those things by, you could first look at the length, and they're going to go to the index 0, index 2, and then minus length minus 1. So you end up with, you can make a whole thing there, but they did it in a for each. So all that stuff is happening inside this for each string name in names, and that's just an easy way. So you always know that when you do this, you go through every item in an array that you have, and for every array you do whatever is between those brackets, and every time between those brackets you use the variable that you put those values in. The current value from the index you are at when every loop is in the loop, where the loop is at that moment, from 0, 1 and 2, or 200, whatever, 10,000, 1 million. At that point, that variable, the information, will be stored into name. So you can work on every array in a string just by saying for each string in name, string name in names. To be honest, and maybe that's why I made this video, and maybe it's because sometimes maybe the syntax or whatever, I don't know, I had a bit of a hard time sometimes getting my head around it. Maybe I skipped that part in the book or something and I started working with it without being properly introduced to it, or I got it from like some yeah, anyway. So yeah, that's why I thought, well, I'll make a good explanation of how this works, maybe for other people. Maybe for people doing also this course, or just want to know how for each works. So I hope that is kind of an explanation how for each works. That we can go maybe a little bit what's going on in this lesson. Now here it's more explained. You can read that. Well, maybe I can read. So let's read it. Below the for each keyword, the code block that contains console write line name will execute once for each element of the names array. So yeah, so there are 3 elements. So for each one, the first one, second one, third one, index 0, index 1, and index 2, it will be executed. As the .NET runtime loops through each element of the array, the value stored in the current element of the names array is assigned to the temporary variable name for easy access inside the code block. So the trick is here that you have now, although we don't go like we don't iterate through like a number. We're not saying, well, we want number, we don't want index 0 or index 2 or 1 or 2. You can never, in this loop, you never see the index numbers. It's actually going, it's looping from 0 to whatever is the end of the array. So it's going 0, it's going 1, it's going 2, it's going 3, it's going 4, it's going 5, 6, 7, 8 million, whatever. So it's looping through the array, all the elements of that are in the array names, and every single one where it is at that point, and that's kind of hidden, but that's to make it easy. This is just an easy way to do it. With short, you don't have to write all that down and do it, and write all the code to do it. It will just go from 0 to 1 to 2 to 3, etc. It's just iterating through all the arrays, and that's actually what this here does, the for each. For every array element, it will do go to 0, look at the value there, store it in a variable. It could be in a string name, it could be an int name, it could be whatever. whatever it has to be the same that's also in the array, of course. So if you have an int array, you put it in an int variable, etc. So that's kind of how it works. And then so you have what you want, and that's the information at that time that's important, relevant for that. So for every element in the array, you can do an operation on it, and that's kind of what is the use for each. So you can just look at them. Maybe you just want to know, like, is there a robin in this array? If there's a robin, make a joke and say, make it Robin Hood or something, whatever. So you can so you look for a name Robin, and then when you find it, you can say change it to this and this. Okay. Now if you run the code with following results, yeah, we can we this is it. Maybe we can look. Yes, so here it says Rowena, Robin and Bao. Okay. It's very simple, but that's the basics of a for each loop. Now here we're going to do the same for an int. Now I can skip all of this. Int inventory. So here we're declaring an int array. That's what the brackets here are. So int is the type. The brackets mean it's going to be an array. Inventory is of course the name, and then these are, then you could say like this is so, and then between curly brackets you can give all this data, and so it starts always with 0. So 200 is at index 0, 450 at index 1, at index 2, 3, and 250 is at index 4. So that's what's in this array, a bunch of numbers. Now we can do a for each statement. So we can go through each element of the inventory array. So we do for each int in items in inventory. Now we look at here what inventory is. That is all these numbers. These numbers are of course integers, ints. So to store them we have to use an int. So here it says for each int, and then we give it a name. The name doesn't really matter in this case because they are it's an inventory. There are items in inventory, so we call it an item. It could be, if this was like a library, it could be like book. It doesn't really matter. This name is just what you're going to use in between these brackets, and something you're going to do with each inventory item, each number 200, 450. You're going to do something with that. So here notice that the for each statement temporarily assigns the value of current array element to an int variable named items. So you create this variable items just for in this loop, just to use it with getting the information and then use it in there. Ensure that your code matches the following. Now we can try this. There's nothing is happening there, so we can do that later. Add a variable to sum the value of each element in the array. Position the cursor like to declare a new variable that represents the sum of all finished processing in your warehouse. Enter the following code: int sum 0. So we're gonna look at what's in the inventory, and we're gonna just add them all together to see how much we have. And we need a sum, sum total of everything. So we make an int, and we initialize it at 0. So you do that before before you do for each statement, so you already have that sum already. So and then you say to add the current values, stored in items to the sum variable, enter the following code: sum plus is items. So you might, I don't know if you know the plus is, but what this says is actually means that it is sum. The new sum, so you have an old sum. Let's say the old sum is 10, yes, and then in items it says 1, yes. So so what you actually want is 10 plus 1. That's, and then that is the new sum. So and this is a way to say how to do that. So you can also write like sum is sum plus items. That would be the longer version, and the short version is sum plus is items. And this is already in the course covered. If you want to know more about it, you can look up the plus is. But this is just so you want, what you want is you want sum plus the items, but you also want to store it in sum. So you take the old sum, add items to it, and then store it back into sum. Now ensure your code matches the following. Now, so we can use this. Okay, we can. Oh, we don't print anything yet. We're not there yet. Anyway, it was so yes. So what happens here is for each item in inventory. So remember, we start at the first one, 200. So 200. It says sum. Now, well, sum is 0 here. In sum is 0. So the first time it goes to the first one is 200. 200 is put in items. So we have 0 in sum and 200 in items. So it's saying that sum is now sum plus items. So sum plus items is 0 plus 200, and it is stored in sum. So now sum, the new sum is 200. Now we go again through the loop. We go again. Now we go to the second index, which is index 0. The first one is index. The second one is 1, and the first one is 0. So the second is, if we go to index 1 now, and that's the second item. We store that in items. Now that is 450. Yeah. So 450 is in items. Now sum was 200 because we stored 200 in it, and it started with 0. So 450 plus the 200 is 650. So now sum is going to be 650, and that is stored into sum. So the next time we go around and look at sum, it has the 650 in it. Then we'll add 700 to the 650. And then we add 175 and 250. We'll keep adding. We're adding all these numbers up. So this simple piece of code just lets you add all the items, all the numbers together. Okay, let's see. Let's write it down. Okay, blah blah blah. Report. This is how to. Yeah, of course. I don't know why they did that. This is going to show it. Yes, so the total we have 75 items in inventory. All right. So I think I already explained everything. Only thing is we displayed it. So what more? Create a variable to hold the current bin number and display the running total. So I think this is this is another example. So let's just look at the code. Int bin is 0. So we have just making a what's the description? To fulfill the final requirement of your inventory reporting project, you'll need to create a variable that will hold the current iteration for each statement, so you can display the bin and the count of finished items in that bin, along with the running total of all items of bins accounted for so far. Okay, let's see how we're going to do that. So now we're going to do bin plus plus, which is going to say we'll take the old bin, take whatever is a bin, we add 1 to it, and that will be the new bin. Yeah, it's actually bin is bin plus 1. That's actually what it's saying, bin plus plus. You can look it up if you want to know more about it. Notice that you use the plus plus operator to increment. That's why it's called, well, it used to be called C++, now it's C#, but that's where the C++ of course comes from, because that was just such a nice way to make that line that you use so much. You always like, yeah, just to make it more simple. Yeah, actually bin is bin plus 1. Here you can see it. So to report the bin number, the number of finished product in the bin and the running total of finished products, enter the following code instead of for each code block after bin plus plus. So here it is console write line bin items around total sum. So what you want to show is what's in the bin number, what's the amount of bin, what's the amount of items, and what is the total sum of that. This code will use your counter variable bin, the temporary for each variable items, and your sum variable to report the current state of your inventory and a nicely formatted message. So it says here the temporary variable items. So this is really used only to store items, information within a dead loop. Again, a list of all the some numbers that are in inventory, and we have sum and bin we are declared here. So we look at the array inventory that's created here, and we so we go to 0, index number 0. We start at 0, the first one, and that is 200 of course, and we put that in items, an int variable that we declare here, that we're going to use just inside of this between these between here. It's going to be used just to show to do things to whatever is ever is at the moment at that current index in inventory. So now we're at 0. We start with 0, and inventory has 200. We store that in items so we can work with it, we can look at it. We could have also looked directly at inventory, but yeah, we have to store it in the loop so we can actually remember what is in there. So this is just a little like, oh, we look at inventory 0, and what do we see? We see 200. What we're going to do with it? Well, let's store it in items so we have memory of it, and we can use it in the code. So it's just retrieving information from inventory at the current location, because it's not just you cannot just look at inventory and see what's in it, because there's so much information. You have to know at what index number you have to look, and that's why what the loop is for. So at this point in items it is 200. 200 is going into sum. Sum starts at 0, so now it becomes 200, because this says sum is sum plus items. Now bin started at 0, and here we say bin plus plus. So bin is bin plus 1. So bin goes from 0 to 1, and 1 is added. Yeah. So now you say console write line bin, so that is 1, because it's no longer 0, you added a 1 to it. So there's one item or one thing in the bin. Now items, that is how many is in the inventory. There are 200 items at this first one, and it says items. Yeah, here you can see how many items are. It said running total sum. So here it is how many things total are in there. Now here we start with sum plus its items, so we just every time we start with 0, then we add 200, then we add 450, 700, 175, 250, just like we did before. We keep adding, so this keeps growing. And then it says console write line, we have some items in inventory. Now this is after the for each statement is done. So, and that's good, because you're no longer doing this. You're no longer you know the total of all the items in there, because you went through every inventory item, you added them up, So sum is now the total of 200, 450, 700, 175, 250, and the 0 that you started with. So everything is added up, and so when you exit this for each, you are sure to know that you have the total of all the numbers in the array inventory now. Here you also look at the sum, but you're still in the loop. So you start at the first one, so at the first one it is 200, but then it's 200 plus 450, yeah, well you start with 0 plus 200 plus 450, and then it's 650, and then you add 700 to 175, etc. So you get this information. So like I said, 200, 650, 1350. You're adding up these whatever is in here until you have it. Now the last time you also see, of course, the total number, but then here to make sure that they know that you actually what actually is the total, that you ended all this research that you did to see how much is in the inventory. You say we have 175 items in inventory. So that's the final count of all of it. Okay, yeah, that's this number. What is it? The 3 of 7. So there's more to come. We can have a quick look at this one. Let's do recap. Here's a few things to remember about for each statements that and incrementing values that you learned in this unit. Use the for each statement to iterate through each element in an array, executing the associated code block once for each element in the array. So you're looking at every item in this list that you have, and for every item you take the item, put it in a variable. That variable is now accessible. Well, you can look at it, you know at that location that you're at, starting at 0 and going through the end, that location where you're at, that element. And you can also count. You can like here, like where you say the bin. If this bin is actually, you could start. You can do it in that way that actually now it is the first item is 1, but you can also do that the first item is 0. Like I think if you do the bin after the bin plus plus after this, then the bin would be still 0. So you start at 0. Now you can set index 0, it is 200, index 2 is, index 1 is 450, index 2 is 700, etc. So you can know also the index number, just going through them. So when you find like something that you want, like say you're looking for Robin, and you find Robin at index number 1, because he's the second name, you can say, well, let's look. You can later in the code you can return that value. You say, well, hey, the name we were looking for, Robin, is in location 1. It's in index 1, and then later on you can say, hey, let's look at the array again. Let's look at the array. Let's look at what the information at index number 1, and then work with it. You can change it, like you say, can make it into Robin Hood. You say, well, deposit like $1 million gold in his account. you know, you can do stuff with that array. Now you found it. You can do that in the loop, or you can also like maybe you want to. Just maybe you want to return that value and say, well, this is what you were looking for. Now you can use it. The for each statement sets the value of the current element in the array to a temporary variable, which you can use in the body of the code block. Yeah, like I just said. So it's kind of, sometimes you see like items and like and then items. So it's just like for both int item and then in items. You know, I don't know what. Yeah, we have new. So now we have inventory, but sometimes they just call it like items, right? So so here here items. Let's do items. We call this items. Of course, now I have to change it here too. items, items, and let's call this item, item. Yeah, so let's save that, see if it's still working. Yes, it's still doing the same thing, but instead of inventory I use items, and then so the variable is called items now. This is the variable, this is the array, is called items. So this is storing the 200, 450, etc. And then I say and then I use the variable item, but of course we're talking about items, so we want one item. So we have the first item is 200, that is index at the index 0. That is put from items at that location, is looked at, is being stored in item, an int variable. Then later on we collect that information and put it in sum and add it to the previous video of previous value of sum and make it the new value of sum. This is what this is doing. So we sum, we are basically just adding all these numbers up. But you see how confusing it can be, like item in items. I know the first time I looked at this, I'm like, item in items, and it's also like, wow, what is happening there? So of course I've worked with it a lot of times, so I know how it works, but still sometimes I like more like items in inventory, something a bit more differentiation there. But yeah, item in items, it makes a lot of sense also, because yeah, but you cannot say inventory in inventories. You know, that doesn't work. So it have to, if you give the array a name that's like multiple things, like you say names, you can also do, yeah, let's do different, like we say, like let's say these are like let's say these are IDs, yeah, IDs. So every person in your company has a number, an ID number, yeah. So then the array become IDs. Now of course it's no longer items. These are every single, so you're taking one ID 200 and putting it in ID. So this is also ID. So now it's the same idea, but now the array is of ideas. So you have one person has number 200, another has 450, and these are very simple ideas. I imagine them being a bit more complex than that, but nevertheless, also, why would you want to sum IDs up? That doesn't make any sense. But anyway, you could just like you could also like anyway. You're going. I just want to show that if you would have like a list of ideas for some reason, and you want to go through it, you would probably say like ideas and then ID. So because this is one single idea at the at where you at the moment, starting at 0, 1, 2, etc. And these are all of them. This is the whole list of them. So you look in the list of ideas and you get one ID. So this is also something, and it could be also names. Well, I didn't do names because there are numbers here. Well, it would be weird to have a name. Well, we can do that. Let's say we're having like a bunch of robots, and they all have names, numbers for name. So we do names, yeah, and then of course this is also names. So now we have a list of names. Robot number 200, robot number 450, 700. These are all factory workers, and they're there. And again, now they're no longer ideas. They're of course one name. So, and now for some stupid reason we want to add all those names up that are numbers and put it in and take whatever its sum is. Doesn't make any sense, but just for the heck of it. So again, we're looking at like a list of multiple names, and we're taking in one name. And yeah, this is a really important thing to understand. That's why I'm repeating it a bit and making some different what do you say, examples. And we'll see this a lot. So now it makes sense. So when you see like names and name, or you see ideas and idea, or you see whatever multiple of something, and you see one, you know, you're just taking one item at a time, starting from at the first one to the last one. That's basically, it's just going from the first one to the last one. But remember, the index starts at 0. Even though it's the first item that you're getting, the index of it is 0. So you also have to go, you have to like take 1 off. So that's why it's length minus 1, because it's item 1, but it's index 0. So it is, if you subtract minus 1 from 1, you get 0. So that's, you can get to every item. So this is like 1, 2, 3, 4, 5. If you want 250 and you find out that it is like the 5th element in this variable, and you want to look at index, you don't look at index 5. That would be a bit, that would be that it doesn't, it's non-existent, because you only have 5 and there's no 6th, because you will be looking at the 6th. So if you look at index 5, you're trying to look at index 6, which is not there. Would probably get a big problem there. But for instance, if you do like, if you want 1, 2, 3, 4, if you want to look at the 4th element in names, the 4th name, and you say, well, hey, in your code you say, well, look at number 4, yeah, there's 1, 2, 3, 4. Which one would you think that you will be looking at? Well, let's look what happened, like 0, 1, 2, 3, 4. Yeah, you will be looking at 250, not at 175, because actually the code starts at 0, the array starts at 0, so index 0 is always where you have to count from, not from 1. You know, in your mind you will know that it's the first one, so you go 1, 2, 3, 4, 5. You say, well, oh, I have 5 elements, and that's the length actually. The code does it too. It says we have 5 elements. It doesn't say we have 4 elements, because that's not true. There are 5 elements, but the index of the 5th element is actually not index number 5, but one less, which is number 4. Again, just repeating it, because it is a bit of a hard thing to grasp, and when you write code it's really easy to make that mistakes where you say, oh, I want the 5th one, and you put 5 in, and you forget that you have to look, the index number is a bit different than the counting numbers, and that's something you have to look in your code always, like when you're making these kind of loops and you're doing like the one with the bin plus 1 and whatever, that you yeah, remember, you're not actually creating, you're just counting how many things you have. You're not looking at the index number unless you do the minus 1, or make sure that you take the 0 in account. Okay, that's like, it's interesting, right? And so these are the two things that I think are the most difficult to get your head around, for me at least, is that the items in items and the name in names and stuff, and because there's a lot of hidden stuff going on. You could write something where it says you write a loop, and the loop says, well, let's look at the length of inventory, and then it says, well, 1, 2, 3, 4, 5. Okay, store that in a variable, and that variable will know how far we have to go, how much, like we start with 0 and we go until 4, the length minus 1, so we go 0, 1, 2, 3, 4, and then you make a loop that starts at 0, and it says inventory, and then it says like item inventory, and then brackets, and then it puts 0 in there. I don't have code like that right now here, but yeah. So so you would actually go inventory 0, like so it would be like, oh, this is really strange code, but so you would be looking at like 0, right? Or actually what you be looking at, it would be more like something like this: names, and then 0, yeah, and then, well, of course that will be like in the previous we had like bin, So is bin is 0, then and then you do bin plus plus, bin is 1, bin plus plus, bin is 2, bin plus plus, and then you look in your loop, you say for each bin, and then you stop when you reach like the end of the array, right? So you look actually at what's in the array. But that's in here. That is what the for each is doing. But it's like hidden code. It's actually going to 0 and to 1, and it's looking at the length, and it's doing the -1 thing, and it's doing all that code, which you could do manually. But it's just making it easy for you. And there used to be a time where I didn't use for each like in the early days, and I just used, that's the way I would go through like an array. So when I started using for each, I was like, oh, this is, it's different. But it's good to know what is going on in the background, because like I said, you have to know that it starts at 0, not at 1. The length is still counting from 1, 2, 3. It's actually not the same. The length and the last index are not you have to do the -1 thing. And yeah, there's a lot of hidden stuff going in, but it saves a lot of coding, right? So you don't have to do the bin plus plus, and you can actually work with a variable called name, and not have to work with like names and then this. But yeah, it's whatever you like. You could do it old-fashioned way too, but yeah. Let's see if we can do anything more here. Again, a recap. Okay, exercise 4.7 exercise, complete the challenge activity for nesting iteration and selection statements. Now let's just look at the code real quick. String, name is Bob, if name starts with B, console bob. So of course this is not, oh yeah, again, like I said, like we're looking at like Robin, but now we're looking at B. But there has to be a loop here, so this is just kind of the basic code. Oh, and now we have to make we have to make it work. Okay, so we have to do like is there an array? Oh, so this is this is going in the array. And there are a couple of B's in there, B, B, and B. And then all of them, those three, they have to be written. So only when it starts with a B, now luckily that name punt starts with does that for you. So the starts with method is going to look if there's a B in the front of the string. So let me see if I can do this real quick. I don't know. I have to make the array. That's annoying. Yeah, it's going to be too much work because I have to put the array also in there, and it's going to be a lot of formatting. Well, let's do that first on. Let's look. I don't want to make it too long a video, but so that's a lot of work. I have to like do brackets around it. Anyway, so basically you just need to do again a for each. You have to make an array, and then you have to put all the strings in there. You have to look at each one of them, and then use that string name is Bob. Yeah, this is a test. Okay, this is just to see how it works. Yeah. Anyway, you would see this. Yeah. So the starts with is going to be really helpful, but you just have to make a loop. You have to make an array, loop again through all the elements of the array, and then and then you do this, like if name starts with B, then print it. It's a pity that I have to do a lot of code for that, but yeah, I think you have to do it on your own, because I don't want to deal with all the formatting. Wait a minute, maybe I can do it. So that's annoying. Oh, that's so annoying. And we still have to do the brackets. It's so annoying. I have my mic in the way of my keyboard, so and if I move it, you're gonna not hear me very hard. It's gonna be softer, so I don't want to move it. It's a bit hard to type this way. Hopefully I can drag and drop this stuff in there. When I was working as a programmer, I had the place I was working at, they gave me a mouse and a mouse mat, which were later on I found out really horrible. The mouse was really like rough, and I was doing a lot of copying and pasting everything with the mouse, and also the cleaning lady cleaned the mouse mat, which was like velvet, and it became like sanding paper. And I was just so enthusiastic about that. Was my first job as a programmer, that for months I kept working with that, and until my complete hand became very painful. And then I realized what happened. I got another mouse and stuff, but so I try to do a lot of stuff with the keyboard, but sometimes I also just like to use copy and paste and move things around, you know. So now we have names. Actually, yeah, that's funny. I already turned it into names. So we have names now. Oh, that makes it a lot better. So let's look at this. That saves me a little bit work. So instead of this sum, which yeah, I don't need to do at all. If name starts with B, that's funny. Of course, this is not going to be in name. Oh, it's going to be again my keyboard is my mic's in front of my keyboard. For each string name in names, if name starts with B, console write line name starts with B. This is not necessary. Let's see. Oh, what have I done here? Oh, it's still int. Yeah. Yeah, that's a good thing when you have like squiggly lines, the red lines. You don't want any red lines. So yeah, let's look. I can look through it, or I can just test it. Let's test it. I didn't use sim. No, that's right, of course. That's not really a huge bug, but not using something is not. I don't think that's a bug. Not using something. I don't know why they like. Oh, you're not using something. Help! We have to tell you that you're not using a variable. Okay, let's do that. Well, it can be indicative of a mistake, of course, but again, it's a bit annoying. The name starts with B. Name starts with B. I'm not doing something. The name starts with B. Okay, let's oh, I also have to do console write line. What was the output that they asked for? Yeah, just this is the output. Names that would be. Okay, let's do it in the thing then. I think it's $, and name. Let's see what happens. Yeah, so I don't even need to write that, it's not even asked, but that's kind of how they wanted to do it. So you see that now we have B123, 177 and 179. So it works. So the name in names kind of was working, but so this is how it works when it's a string. I had to put all the data in. I made an array string with all this information. We start at 0. We look at B123. We put it into name. Yeah. Then we go to this if statement. The if statement says if name. Let's see. Let's put this a bit. If name starts with B, so it's looking at name. Now it says B123. Yes, this is true. So if it's true, it does whatever is between these brackets from the if statement. Oh, brackets, the yeah, you know what I mean. And then a console write line, and then it gives you the information in name, which is the current array, what's in the current array location index. So, and then it just gives you the information. So yeah, it works. Yeah, so that's the assignment finished actually. Hint. Here's a hint. As you loop through each element in your array, you need an if statement. If the if statement will need to use a method on the string class to determine if string starts with a specific letter. If you're not sure how to use an if statement, please. Yeah, okay, so that's already covered. And I think I just talked about the statement. So where do you get stuck? Blah, 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 blah. Okay, continue. Now we can check if I did it right. So here again, you put all your stuff in. They made it order ideas, and then which is funny because they used name in the example. But anyway, so order ideas. So you see multiple order ideas, and funny thing is that they're actually strings and there are numbers in it. Yeah, I guess ideas have numbers in them too often. So yeah. So that's not a big problem, but so these are not numbers but strings. And then it says order ideas, and every order ideas, every element in order ideas is put into order ID. The number index number 0, the first one first. So the first one B123 is put in order idea, and then here it goes through everyone. So it looks if order ID, and that is of course B123. But starts with B. Now this is like a method that's being used on this string variable, and it looks if it starts with a B. Now if it does, then it's a yes. It says true. Now if something is true, we do whatever is between there. So now if it would have been C234, it would have been false because it doesn't start with a B. So if it's false, it doesn't do whatever is in here and just goes on to the first one in the loop. But because it is true, it will do console write line order ID, so it's going to write the order B123. Now here with C, it's not gonna, it's going to be false. It doesn't start with a, so it's not going to do the order ID. It's also going to skip A and C. Then B is going to be true again because B177 starts with a B. So it's going to go into this between these. Between the if after what's going to happen after the if statement, and it's going to tell them to write the order ID. So B217 is going to be written. G is not. It's going to be false. It's not going to start with a B. C is going to be false. So again, this is not going to happen if it's false. B is going to be true because it's true. It starts with a B. it will be written to the console. That's how it happens. Okay, now my code was a bit different, not that much. Basically I just some green stuff here, and it basically just different names I used, and I used their example with it starts with a B. I kept that in, and I used their names and my own names. So I just had to put create it into strings instead of ints. So that's why it's a bit different. Whatever they made up this order, a whole order ID that wasn't really, I don't know if that was. It doesn't really matter. These are just variables, as long as it makes sense. You have some wiggly room but it's really, but I'm not gonna say it's not important how your variables are. And this is like the solid principle. It's like if you look at this code, if this would have been like, let's say we'll make some crazy code, yeah. We call this CFRT, yeah, and then this also has to be CFRT, yeah. I don't hope that's not something bad I'm saying or anything, but so we just have this random thing. Now if you look at this string CFRT and then you see B1, 2, like what is happening here? I see all this weird like C15, B1, all these weird things that I don't know what they are. It could be anything, you know. I don't know if these are IDs. I mean, CFRT doesn't indicate that these are IDs or anything else. They're CFRTs, if that even means anything. So because CFRT is not really actually saying anything about the code, and it wasn't meant to be, like the person who I put CFRT and just hit a few keys and I added up with CFRT, and then I kept using that. Now maybe this is in CFR, you know, and then this is in CFR, and then this is in CFR. That could have been kind of helpful, because now I know, at least you know that CFR has something to do with CFRT, because they look alike and it has one letter less, and then and you know that's for each, so it makes sense you're putting CFRTs into a CFR. And but because CFR doesn't really say anything, it has nothing to do with the reality. It's just like a random arbitrary thing. I mean, you could have also done this. You say like C, and then you call this C, yeah. Yeah, C is this, and then this is let's say this is on B, yeah. It still works, but here you're putting all this weird stuff in here, and it's going into C, and C is not, it's just like A, B, C, D. It's just like a random variable name that doesn't say anything, has nothing to do with the fact that these could be IDs or anything, or names, or number, or no, not numbers, but like some kind of yeah, whatever this is. It's not C. C is just like yeah, it's just in like you go in match, say, well, x is y and z and whatever. It's just a variable that doesn't explain the content. So, and then C even goes into B, and then you're working with B. Now at least B and C, they're kind of like working together. Like C, it kind of makes sense, but if B would have been like ERW, and then here ERW, and then here again ERW. The code works, but come on, like ERW, it doesn't even look like it has anything to do with C. Well, actually it's taking one element from C, from the array C, and putting it in there. You'd even know C doesn't even indicate that it could be an array or anything. Like if you would have like even if you would have had yeah, when you say names, you know that there are multiple names. Actually, there's, you know, and if you use name, you know there's one item in names. It gives so much more information. You're talking about names, people names, or identification of things, items, or like the IDs things. Like if you're working with IDs, order IDs, you know that it's not just an ID, but it's the ID of an order. So the more information you put in that variable, the more your code makes sense and people can read it, because then you know, oh, The numbers are ideas, and they're ideas of what? They're ideas of orders. This is a list of orders, and we have to look through them because we want to know what kind of orders start with a B, because they are all have to ship today or something, you know. So then the logic becomes a much more these variable, like without these variable names, all you have is like the name starts with B, and you know, and you can find out that, yeah, you're iterating through C, and that C is a variable. Yeah, you can kind of, like, if you think about it, yeah, it's obvious here that it's an array, and but why is the what's the array about? Why is this happening? What's the content of this? And then, like, even if you scroll down a little bit, now you don't, like, if you're here and you say C, E, R, W in C, you don't know what is in C. You don't even you can like, if you might forget what the declaration was here, like that's the string and that there's all this information in it and whatever. You just see a C and you're like, well, it's a for each, so it's an array, and it's going into ERW. But what is ERW? Like, what is that? You know what? You know. So yeah, so that's kind of what the solid is, and also, like, when you're writing code, don't try to write it like this, you know, like whatever. Don't do weird stuff with yeah, try to make it look a bit like it makes sense and all this, and this, like, this is when you're working on. If you don't need this, remove it. You know, why leave it for somebody else? Unless it needs to be used later in code or something. It's code that you maybe want to reuse or refer to or whatever, but don't leave old code in there for too long, you know, when you know you don't need it anymore. Just get rid of it. Let's go back, because I don't like the way this is formatted right now. Let's go back, let's go back, let's go back. I think we're back. Okay, so yeah, this looks so much better. Hey, we have an array called names. These things are names, you know, or order IDs, whatever. Maybe they're robots, that's why they called B1, or maybe they're products like the cars or whatever. That's why they have these weird names. But these are names of something with these weird names. And then you go, like, look, put what will you with the names? Well, you put them in a variable. You take one of them, and that variable you call name, because it's one name. It's not, you know, you're still talking about names, just one of them, and then you can say, well, look at this name, and it starts with a B. This code is so much more useful than if those variables would be weird. So there's a bit of extra information there. I think I want to say, well, why not do the knowledge check? Then we're done. Check your knowledge. Which of the following can be used to access the third element in an array? So the third element, this is what I talked about all the time. So what do you think? Is it the third in my array 3, because it's the third element? So you would say, well, the third element is my array 3, right? I mean, this is all my array. The only thing that is different, well, this one is different because these ones have brackets and these are not brackets. Now, this is wrong. You don't use brackets. You use brackets. You don't use these. This one. So this one is. So this is one of these. So it's either 3 or 2. So what is it? 3 or 2? Well, it's the third element. So why would it be 2? That must be wrong, right? Well, if we did it start at 1 or at 0? The elements, because it say we're gonna access the third element. Access it. So if you look at the third element, yeah. The first one is at access point 0, index number 0. The second one is then at access point 1. The third one is at access point 2. So the third element, actually, to access it, you have to say number 2. You have to do -1, remember? So 3 minus 1 is 2. Now, they could have asked, what is number 2455? Well, it ends with a 5. 1 less is 4. You know, 2454 or something. Whatever I said. I don't know what I said, but Anyway, one less. So we do one less. My array is 2, and this is really important to know in code when you're writing these things and you're accessing them, because you may find that it's third element. Hey, we're going to work with the third element. Third element, put it on the screen. This is oh, you're going to be paid 2,000 euros, 20,000 euros. No, it was oh, it's the other element. He's going to pay 3,000 euros, not 20,000. You know what I mean? So there's going to be a big difference. Oh, let's add to his bank account whatever in the third element. Well, if there's €1,000,000 in that third element, you're going to add €1,000,000 to their bank account, and maybe the actual element was maybe 50 euros. Okay, so and that person that has the actually €1,000,000 is going to be like, what's going on? So it's really important. This is something that can happen, and this is like a logical error, where you would like in your mind you think, well, I've done it right. We're looking at the third element, and because you put a 3 in, because you think you're looking at a 3 anyway. I think you get it now, right? Which of the following choices describes the correct way to create a new integer array with 3 elements? Which of the following choices describes the correct way to create a new integer array with 3 elements? Now, int, that makes a lot of sense, because we have an integer array, so if it would have been a string, it would have been started with a string, but there's no difference there. Then we have the brackets, that is okay, an array, like if you would just say int like this, you're actually creating a variable, you're not creating an array. There's just like one thing to store things in, and this is a whole list of things to store things in, from 0 to whatever, and you can put lots of stuff in it. So this is the way to declare that my array is actually an array. I mean, you can call it my array all day long, it doesn't matter what you call it. You can call this my array, but it's not an array. It's an int variable, and this is an int array variable. So now the names my arrays are the same. Is now we know that the last one is wrong, so it's one of these. Now new, oh good, we're saying that it's a new thing, yeah, a new object. Int is 3, int is 2. So the difference is 3 or 2. Now we're going to have to think about the 0 and the 0 start point, you know, that we're starting at 0 and not at 1. Well, we're starting at 1 when we're counting for ourselves the length. Like the first item, you say, well, item number 1, item number 2. But the index is index number 0, index number 1. Okay, so which of the following choices describes the correct way to create a new integer array with 3 elements? So we want 3 elements again. So we want 1, 2, 3 elements. So you have the first, the second, and the third. So you would say 3, right? So int 3. Well, you know, well, wrong, right? Because you're starting at 0. You have 1 less, so you're not counting 1, 2, 3. You're counting 0, 1, 2. So you're taking 1 off, -1, length -1. That number that you want, 3, you take 3, you do -1 on it. -1 on 3 is 2. So you say int 2, 0, 1, 2. Those are the index numbers. And when you declare how actually, am I doing it wrong? Yeah, I'm doing it wrong. Because here you're saying how much you want, how many you want. It's like the length. I'm sorry. The thing is, when I'm trying to explain things, you go on a tangent, like from, oh, this and this and this. Yeah. So again, because this whole 0 starting at 0 thing is such a big thing when it comes to these arrays, you can get confused, because we're not looking at an index. We're creating an array with 3 elements. So how many elements? 3. So we want that, so we're giving we're giving an amount. We're not using an index. The index we use later to access them. Now we're giving an amount like the 1, 2, 3. So yeah, indeed, because we're giving an amount, now we can use int 3. This one was a bit tricky. I was like going all the way in the wrong way. But so yeah, this is not, when we're here, we're saying, what we're saying is, we want a variable myArray. That's for sure, right? Now, what type of variable? It's going to be an int array. The array is the brackets. It could be the string array. It could have been something else, but it's an int array. So this variable is an array variable. We'll also call it an array, but it could have been called anything. And calling it an array doesn't do anything special to it. Doesn't making it any more of an array than it does. These brackets make it an array, and the int make it so that it only holds ints. Now, then we say is, because what is this new int doing? It's saying how many items are going to be in there, how many different ints are we going to store. Now, the fact that we're storing, when we call them, we say we want number 0 and one number 2 and number 1 and number 2. Those are our options when we have 3 elements. When we declare it, we're not actually looking at that. We're not starting, we're just giving a number of how many we want, and that is like the normal what we use in every day. Like we want 3 apples, whatever. We say we want 3 elements, and those elements are going to have indexes 0, 1, and 2. But that doesn't matter. We're not going to put 2 in. We're going to put in 3. I hope I'm right. If I'm not wrong, we're going to find out. Which of the following for each statements is syntactically correct? For each int value in values, for each int value of values, for each int value with values. Now this is interesting, actually, because I'm of course in Fruit Code Camp. It's good to make sure when you start this, you have to do two things. And you have to go to this study, the learning area in Microsoft. Then here you have to tell them that you finished it. I haven't yet, almost. And then here they ask a question, and this question is about whatever you just learned. And when I looked at it, what I do, I look at it, go down and look at it before I start, so I know that it's going to be easy to answer this. And this is the same question for each int value of values, for each int value with values, for each int value in values. Now, I looked at it, and now, like I said, I know a lot of different programming language. I know a lot, yeah, over 10. I know a lot of them, and if you count all the different things that you have. So I used so the for each, and I have a lot of for eaches in my head. So and it sounds off. It sounds like it could be value of value with values, in values, but I already thought, well, it's probably going to be in values. You know, that's pretty sure that it was in values. But yeah, of course, it's always good to look. And then here again is asking the same question, and this is just syntax. This is just how the language works. It could have been off, it could have been with, but they didn't do that. They chose in, you know. So if you look at the code that we created, it says name in names, and that's just, yeah, it's like how people say things. You know, some say tomato, say some tomato, you know, whatever. It is just, we choose in value. The thing is value in values. So this is really, you have to just know how to write things, and it's for int value in values. And the other ones are wrong. So let's see if I made any mistakes. Nope. So that was right, what I said. Yeah, and there's really, yeah, valid syntax. You know, it's just knowing the rules, how to write things. Index are 0 based, so an index of 2 returns the third element in array. And this is interesting. It says indexes are 0 based, but we're not doing, Oh yeah, this is about index. Yeah, about accessing. So indexes are zero based. Index of 2 returns the third element in an array. So this is the first question, and here, correct is the correct way to create an array with 3 elements. It's not talking about how the whole thing where I went off that I had to do 2 and stuff, but yeah, you can see that that was the difficulty of the question. So now I'm done. I can read the summary. Your goal in this module was to work with sequence order IDs programmatically to identify potentially fraudulent orders. You create an array of order IDs. Well, you didn't do that. I did that earlier. Then iterated through each element of the sequence, look for common fraud trait. Array enables you to store each order ID as an element of a single variable. You addressed a specific element of the array using an index, a zero-based numeric value. You were able to retrieve and set the value of each element. You iterated through the elements of the array to inspect or output each element value. Because that's why you do it. You have information and you want to look at it, and you have to, when it's an arrow, it's a whole list, and you want to make sure that you didn't skip anything, and that you didn't stop too early. And for each does that. It goes from the first one to the last one. It goes through every one. It puts it in like a variable that you can use, and you can look at it, and you can do all kinds of things with that information. And you probably could even, now when you find something, you can even go into the array and chase things in the array, because if you like keep tabs of where you are, like you do like an I++ or something, you put like you keep track of where you are in the array. Imagine how difficult it would be to handle related data if your code if you didn't have a structure like an array. You would need to know ahead of time just how many data elements you expect to work with a defined separate variable for each value. That would create a brittle solution. Yeah, well, if you didn't have an array, I mean, you could. There was a time when arrays didn't exist, right? But then you have to program it. You have to program something that works, like looking through an array and all that stuff. Like I said, you can do that. You can just say, well, what is the length of the array, and then make a loop where you go from 0 to the end -1 of that array, and you can look through every element. And that's actually what for each is doing. But yeah, because that is something you have to do so many times, they just made a for each for it, so you don't need to code that in, go iterating through every element, and they make for each just to do that for you, and hide that kind of code. And if you don't need to know where you are if you don't need to know like at what point you are in the array, if you just like, let's say you just want to look at every element and like say look like what starts with a B, yeah, that's perfect for each. You can just go through it, every element, look at every element, look at like it does start with a B, and then put the B, and then output that. It's a very yeah, but if you want to do more, like really work with the array itself, you might want to keep an index where you are at it, and do that kind of stuff. And even make not use it for each, but maybe something else, I don't know. But yeah, for eaches are so common now. You probably use for each for that too. Arrays can be sized when created according to the amount of data you need to work with. As you become even more familiar with arrays and similar data structures, you'll often use them in your applications to process and manage data. Now, like I said, like the thing is, like if I wanted to look, if I'm looking for like the B, yeah, and I want to change the B into a C, right? Look at all the names that start with a B, yeah. I would look at I could use this, but how can I change actually the array, like to change it to a C or change it to like something completely different. So if I could say, like bijvoorbeeld, let's say name is name X, yeah. I want all the B, everything that starts with a B, I want it to be turned into X, right? Here, cannot assign to the name because it's a for each iteration. So it doesn't even allow me to change name because it's only meant, name is only supposed to be taken from names, from the array. I'm not allowed to change it. And that's interesting. That's interesting. And that's, you know, because it's part of the for each. Now, I would never try this, but now I show you, like, and the thing, what would it do? Even if I would change name, it wouldn't change anything in the array. It would just change this variable that I put a lot of effort into putting in whatever is in names. We're working at yeah, the input, the content of the array at a certain index, and that's in name. Now we're turning into X. That could then why even do it? So it's not letting me, it's not allowing me to do that. That's interesting. I cannot assign to it. But why would I do it? Well, actually what I want is I want to change whatever is in name. Dus I want to change names. Yeah. Now here it says X again because it's a string and it's a string arrow. So how? So I would have to actually do like this. Now again, it's giving me an error because being used as a type. So I have to want to do what I really want to do is know where I'm at. So let's say I'm at 0. Now it can't. Now it's not giving me errors again. So I'm changing names. Yeah. Like it's going at B. I'm changing it to X, right? But the problem is this is 0. I want to do whatever I'm at. If I'm on 0, I want to do 0. If I want to do 1, I want to do 1. At 2, I want to do 2. So I would have to make an int, yeah. Oh, I'm getting. I need to. Anyway, so I need an int. I is 0. Yeah, and then I do like something like I plus plus. Yeah, and now I can put the I in here. Oh, I can put the I in here. So that's 0, and then here it as 1, and actually that's not going to work very well. Because we're going to start with 0. So if I turn 0 into 1, I could start at -1, but no. Like if I'm going to start for 0 because that makes it easy, and then the first one, it has to be, this I has to be 0. So the first name is gone, or else I'll be doing the next one. So that's not right. So the I plus plus is going afterwards. After I've done, the next I is going to be 1, and the next I is going to be 2, and the next I is going to be 3. But the first I is always going to be 0. So I'm not doing I plus plus before I actually put an X there. Now let's look at what happens. I don't see any errors. We're going to please just see X, 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 right? Yeah, no. Oh, of course, because name, I didn't change, I was not allowed to change name. But if I would look add the things, we can do this really easily. Boom, we're doing it again. This we're not going to do that again. But now you're going to, if it starts with an X, we're going to show it, right? I can put the E++ there. It doesn't really do anything here. Okay, no mistakes. So yes, so you can see that all the B's are changed to X. Now, if you don't believe me, let's put this outside of the loop. So it's going to do it with every, I can even remove this now. Yeah, so it's going to do this for everything. Oh, I removed too much. Wait a minute. Did I remove too much? No. Did I do anything? Why don't I see an X? Names. Why is X? Is this not going out of the scope? Because there's a scope, you know. There's a scope there. So, is it not going outside of the scope? Because the B's should be X. I thought I was turning them into name I is X, E++. Oh. Let's put out I2. Just to get some information. So yeah, I think it could be that it's not in the scope. Because I'm changing names, this array, inside of this loop, inside of the for each, or I'm doing something else wrong. Names E is X. Let's just do it for all of them, just for to see what happens. And this is like debugging for me. Like I just simplify my my code. Control S. X, the name starts with a B. Can I go up? Wait a minute. Okay, this is the full input. So first, it does the original one. It just shows everything, but everything is turned to an X, and that's exactly what you see here. The second time, everything is turned into an X. Now, why wasn't the previous code working correctly? So I want this only done to the B's. Let's dump this in here, and then let's try it again. Don't change too when you're debugging. Don't make too many changes. Why is it taking so long? Oh, I know why the second one didn't work, because it no longer started with, no, wait a minute, B. So here it gives me the answers B, B. Oh yeah, of course. So I'm going through the loop twice. So the first time all I'm looking at is the B's. So it's saying B1, the name starts with a B, B2. Oh yeah, 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 now it makes sense. So this 1, 2 and 3, I'm so stupid. The 1, 2 and 3 are my I, the iteration, where I'm at. Now this is a big problem. I want to find the index right, but I am only going inside the loop when I find a B. So it's 1, 2, 3. There are 3 times a B. So only the B's are being changed. So if you look here, 1, 2 and 3, because this is the second loop, the number 1, index 1, no, this is, yeah, so the first index, the second and the third index are, or 0, 1 and 2 are changed to an X. But it was supposed to be the B's, and I saw 2 B's. I thought, well, my code is not working, and it wasn't, but now it makes sense why it's not working. So yeah, so what is the problem? Well, this I++ is supposed to keep up with the index, right? But it's inside this condition. So I would have to put it here, yeah, outside of the condition to make it work. But again, now it's in front of, it's going to turn the 0 into a 1, and then index 0 is going to be 1. So we don't want it there, we want it actually, oh, I have some little space right now. Yep, I want it actually here, after the first one. Yeah, so we want it after the first one, and that's it. Let's make the code a bit more compact. This was not necessary. Then this is not necessary. Right. So now it's a bit easier, so smaller. Okay. Makes it easier to write, work with it also. Let's try it out. So again, now we've seen X here. I know that the last one was a B. I know that halfway through was a B, and it started with a B. So B, so it says B 1, 2, 3. That's the first one, and see first the name starts with a B. Wait, this is an old one. Yeah, this is what I want to be. So this is correct. So the one that was a mistake, because the first one we know is at index 0. So B1, 2, 3, that's the first one, but it's index 0, starts with a B, right? But then I changed it, names I, and I is then 0. That's what I'm printing here. I0 is X. So I'm changing this B1, 2, 3 into X, and here I'm at index 4. I am also changing it to X, and here at index 7, which is now working correctly because I put it outside of the if statement, and it's after the if statement, not before, so it's doing it correctly. So now I'm getting the index numbers, and I'm using the index numbers because now I'm getting them correctly. Also, I'm using them correctly to change the B's into X's. So then we go and we just look at all of them. And yes, of course, we know that the first one, and this is where it starts, the first one is now turned into an X. That was at 0. And then at 4, it's turned into X. Okay, look, 0, 1, 2, 3, 4, 5, 6, 7. And the seventh index is also turned into an X. So it's working. Phew, now I don't even know what I'm doing anymore, but whatever. Yeah, I'm just showing you how like if you want to work with, actually, if you want to change the content of this and not just look at it, then you have to use this I++ to look at it and change it. Now, what you also could do is not even use a for each, but just actually use the I and look through the strings and do it that way. And you have to use the well. I think I'm going into it too much. I think there was an interesting exercise, but yeah. Yeah, I think this is probably still the best way to do it, but you can also just go use the I and then look at the first one, the second one, like I'm doing here, you know. If you have a loop where you're incrementing x with I++, like here, you can just look at names 1. You could just, instead of like name starts with B, it could have been name I. Okay, so like this one. Name I starts with B, right? Well, it would be not name, it will be names. I starts with B. Let's see if this still works. It still does the same thing. And so how come that this still works? Because I'm actually tracking the index number from 0 to whatever the end is. I'm looking at it. Now I could also change this loop into like an iteration loop, but to look at I. And actually that would make maybe even more sense, because as a programmer you can actually see you're working with I here, you're working with I there, you're working with it here, you're using it, you're actually if you only want to look at it, yeah, you put it in name. But if you're going to work with the actual array, why not just directly look at it, right? You could say, well, it's safer just to take it out and not actually do things in it with this, because like here you say names I is x. If you do that by accident and you're overwriting information, etc., in the array, you might, if you do that unintentionally, yeah, then it could be a big mess, because now your data is corrupt, right? So and once you do, and this names I starts with, yeah, it works, it's great, but again, like maybe there's something for each statement where you just put it in a string and then work with the string instead of, it's also, this is a bit longer than working like with the names, you know. If you it's more also, and you also have to have the I plus properly, so yeah, it's more work, of course. Yeah, but like I said, I started out with doing it that way, and then later on I used it for each, of course, but like it's still, I still like working with basic building blocks, you know, like going through it, like looking at it the way this is actually, now you're looking actually into the array directly and saying, well, does it start with B? Here you're putting in a string name. Now it's no longer, you have to remember in your mind, oh, I took this from names. Now name and names, it's really obvious that you took name from names, but if people don't put like weird names in there, like and then they go and you're like, okay, and now you're working with those kind of information, like, are you going to remember that Normie came out of Greg? You know, are you going to remember that? So it's important to yeah. So that's kind of thing where working directly with it could be an advantage, because now you know you're actually looking into the array. Especially if you, and also you need to work with the array if you're going to actually change it, and or like take information out, change the information. You can also do, does this work? Oh, I'm doing the wrong one. Yeah, That is like that was that was a Boolean there. That's like comparing it to each other, and you cannot compare an array with a string. But yeah, now I'm adding x to the end of it. Let's look at this. This could be fun. Now I work a lot with program languages like PHP and Java and all this, where you can do a lot of stuff that it kind of like understands what you're trying to do, like overloading and stuff. And overloading is when you're like trying to, you can do multiple things with one thing, you know. Is it doing it something? Probably did, yeah. So now here we look, we see a couple of x's here. You see b. Now here we first, this is the first loop. We're not doing anything here. We're just looking at the b's. And then here at the second loop, well, actually in the first loop here we're looking at the b's. We're showing the b's, but we're secretly changing them and adding an x. So with the second time when we look at them and do nothing, we're gonna get the b's with an x behind it. You see b123x, b177x, b179x. So now we're actually changing the array. Oh man, I hope that's it. No more stuff. No more stuff. Let's look at complete module. So now you have the module here. You get either you get, when you have them all, you get a badge, yeah, and when you have this, you get this one little achievement, yeah. Now then you go back and then you say that, well, this is where you looked at it. It was the achievement. Now you can say here, yes, I completed it. Store the iterate through sequences of data using arrays and for each statement in C#. Module on Microsoft Learn. Okay, so we did that. So you hit that button, then you have to do the question. Now again, it's just a question of how they decided to use this for each, and it's in, not with, not off, not anything else, not a, not whatever. It's in. So you just have to know that, remember that, it's not hard. Now we can check, submit and go to the next challenge. So here I'm like halfway through, that's nice. Here we are. Now I can go to the next again. You can look at the question. Which of the following is a bad reason to use the code comment? Now there are some things, you can read them, maybe already answered for yourself in your mind. Here, to describe high level intent of the code, no. To temporarily comment out a line of code while evaluating the future in a different way, yeah, just like to explain how Neil's C# keyboard works, no. People have to understand the C# by themselves. The high level intent of the code, you have to either put it in a different document or talk with it about with your colleagues, or it has to be made clear to you from your supervisor, whatever. And that has to be in some other area. You know, when but yeah, it's just to, like, you're working with some things, you don't know what you're doing, you're like, oh man, this is not working, well, I'll just comment it out and I'll figure out later. It's while you're just figuring things out. So yeah, I don't click it yet, I'm just gonna look at the next one. So comments is gonna be the part of the next one. Did I already? So this one we don't need anymore. This one is gonna be the next one. So I'm not going to do this right now. I just want to show you how the aftermath is of this whole thing. So now I'm setting this ready. This one is also here. Now I can look at my where is, oh wait a minute, let's see. Oh yeah, it's in another window, sorry, I have another window open. So here you can see this, the first one that you do. So you have to do 7 items, and then I'm here at the second one. Now I just open it, but like say, so the second one, third one, fourth, fifth, sixth. There's 6 like are they models? Yeah, they're or parts, no, 6 parts, and they have like different amounts of like about 8 modules each, 6 or 7, but around 8. So I'm on the second one. So I just finished this. This was not synced, or not. This was like this one. I just added this one, and then I have to, like, the way I did it, I just showed you. If you do all of them one by one, you will get to the end, and then here, and then you will get a badge. Maybe I can show you the badge. No, this is information. This is my account. So you see I have 10 badges and 1 trophy. Well, the trophy is if you the 6 parts, so you need 6 trophies for every part. Every time you finish one part you get 1 trophy. And the badges, so like the first one had like 7 modules to it, 7 items that you had to do, and so I had 7 badges, and now I have like 3 from the one that I finished for the next trophy. If you have all of them, again you have to like coordinate it with, every time it's between free code camp, you have to go back and forth, make sure you do everything at Microsoft, make sure you do everything as free code camp as intended. Like actually basically you have to click on this and then answer the question correctly and check your answer, and then you can go to the next one. And you need all the trophies. Where did I? Yeah. So you need all the badges, you need all the trophies. So in Microsoft, where am I? In Microsoft Learn Space, you have to also go through all the steps. So here again, I can start, and then there are several parts that you have to go through. Continue. There are like 8 parts, 1 of 8, and then when you all finish them, like we just did with the previous one, again you can say I've completed it, and then you know the answer to the question 100%, because it's part of what you've learned, and you will be very clear what the answer is if you've done it properly, and hopefully you learned some stuff. Let me see. Yeah, and then if you do that 6 times total, you will have all the trophies and all the badges, and you have all the steps here. Like you have to always collect everything. 7 out of 7, 8 out of 8, 8 out of 8, 6 out of 6, 7 out of 7, whatever you need to do. If those are all done, you'll get it, and it's free. So you just have to go all through it. And for me, it's a lot of repetition, of course, but there are still some. Yeah, I don't mind a little bit of like getting things like getting things that more clear. And things, of course, you get things more clear if you go through it over and over again. So yeah. But again, of course, I do it for the certification, so luckily most of the things I kind of know already. Yeah, but who knows, maybe if I go later, but near the end, maybe there's some things that let's look at this. Like I showed you how I debug. I put like I output information. I look at variables in the code. I just output the variables. I turn things on and off, simplify things, and find out where the bug is. And so I don't need like very complex ways to debug. But I like the fact that there's a whole thing about it where they do things about debugging and stuff, and So I'm sure there's some interesting stuff for me in it there too. But yeah, like I said, like I work with C, I work with C++, Java. I coded already a game with C Sharp, so it shouldn't be too much of a problem. But yeah, so yeah, and then you get the foundational C Sharp with Microsoft, and it's free. It's from Microsoft, and you know, and of course you need also and yeah, it's just that's something to show people. Like I can tell people I can work with C Sharp. I can show them my game that I made. I can show them my code, of course. So I can prove that I can work with C Sharp without the certificate. But yeah, I have to like actually show my code to people, or they have to give me an assignment and then I have to do it, and I can show that I can actually work with C Sharp. So having that certification makes it just clear I do have at least at a certain level I know my stuff to be able to get certification. And I have plans for a lot of certifications, a lot of them, because some of them are free, some of them can be a bit more expensive, but not like thousands, like more like there was one that was like sometimes they're like around 250 or 300 or 60. So it is yeah, it is but yeah, of course it takes time too, so I have to look at what I want to do. So I have one that is like machine learning that I like. That's machine learning and Python, because machine learning is done a lot with Python because it comes from academia and they love Python. And so whole machine learning is really connected to Python. Now, from all the languages that I know, Python is one of the ones that I, of course, looked at some point, and it's not. Like I said, it's like if we know so many, like I know, I've a lot of experience with like basic languages, with C, C Sharp, JavaScript, PHP. It's pretty much like it's going to be not hard to just add Python to that if I need to. On the other hand, I want to use C Sharp in my game Supernova and give the computer some AI abilities in maybe fighting, strategic, tactics, maybe some communication with the AI, and make a very interactive game with the AI, which is in C Sharp in Unity. So I might not even need to really go to. I don't know if I'm gonna. For that, I don't need Python yet, but there is also from Free Code Camp. There is a there are some other courses that you can take. So this is to say they have a lot of them, but they say that earn free for this core curriculum. They call this core curriculum. Now I know web design. Maybe I will do some of these. I don't know. Front-end development, JavaScript. I mean, of course, I know how to work with database and everything, and all this. I just finished HBO web and interaction design, which is like university level web development education. So that was kind of included, but you know, maybe these are free certifications, and like I said, it's always good to to go through a course like that if you want to, and get more things at the front of your mind and more into maybe learn some few extra things that you didn't know yet. So there are lots of certificates that I can get. This machine learning with Python is what I'm really interested in at the moment, because like I said, I already know web development, I know the languages like C Sharp. Machine learning is a new area for me. So it would be fun to learn that. And the fact that they do it in in Python, uh, is not a big deal. So machine learning with Python certification. So it's Python and machine learning all in one. So I can learn a new language, which I love, of course. Why not add Python to all of them? And learn machine learning and then learn it and get a certification for Python and machine learning while learning it. So, and then also TensorFlow and getting into the whole AI business, which I think is going to be a big deal in the future. And it is right now. It's no longer future. It is a big deal right now. It's a really, really big deal. So, yeah, to be at the forefront with that. I've done a lot with AI when it comes to like images and making videos and kind of interesting stuff with that, videos and stuff and storylines, and I've written a story with AI help, and I'm also using AI in coding is going to be a big thing, which also something I don't, there's not a certification for that I think yet, but it's something that is going to be a big deal. And so learning machine language is gonna, if you know, I work for money like everybody else, and I think there's gonna be money in machine learning too. And also I want to challenge myself, like, you know, I really love very complex stuff and learning things and trying to understand things that are difficult and challenging. So although web design is fun, in the end, once you've learned all the languages and you got all the skills, it can be maybe a bit repetitive. And machine learning, I think, is still developing. There's a lot of complexity there, and that's what I love. I like the complex, like algorithms and how complex machines or the complex machinery of the AI, and getting more new things. There's so many things to discover there, what you can do with AI yet. What we can do while these technologies is developing, we have so many implementations of it in real life, and adaptations of it, and still AI, although it's really cool right now, like because of the things you can do, great imaging, helping with coding. You can ask anything in ChatGPT on your phone, it will answer things. And I think that's something that's going to be all over the place. And yeah, I think the time where we're going to have like robotic assistants is really at hand right now. We already have it on our phones, we have it on our PCs and Macs and whatever, and iPhones and Android devices, and we're gonna have robot dogs fixing us a cup of coffee with the robot coffee machine and stuff. And yeah, AI, there's gonna be a way where AI is gonna be in everything we do. Like it already, we have like programming code. Like when I write a program, I write it with an intelligence in there. It will react to whatever you do, and in a way that is pre-programmed intelligence. And like a calculator can calculate anything you put in it. It's pre-programmed intelligence, and in a way AI is also pre-programmed, but it's not but because it works on its own, like machine learning, it learns on its own things that go beyond what we can directly put in. Like I don't have to put in manually responses that the AI gives. It will look at the way we talk and make a response from that knowledge base that is appropriate. You know, the language models. So they make images from the images they look at, can create the text and make something sound good the way that we expect it to sound. And yeah, there's actually quite a big thing that people who don't understand how AI works thinks that their intelligence works, that the way they speak and the way they think, they actually think there's like a thinking person behind the AI. But in basically it is just a program that is capable of recreating what we expect to hear from another person, and it's mimicking, or it is acting in a certain way, and the reality, however, is maybe that the thing is that when you act at such a high level, you almost become the thing that you're acting, right? Like a great actor can lose itself in whatever they're doing, in their persona for the film, movie, or stage, and they can almost become that person because they're always dreaming, thinking about that, being that person, and so involved in the role and playing it and doing the things that, saying the things that that person does, and pretending to have those emotions, or actually having those emotions by inducing them some way, that they become the persona. And that's kind of like how I could be actually be like singularity, where we've given it the ability to act as a human being so much that for us it is like indistinguishable, because everything it will say and do is so much like we would expect it from an intelligent person, that we think that it is an intelligent person, and so it has singularity, so it is a being, something that has mental capacity as us, but we have to, but it is still an actor, it's acting like it is. It could even have more capability than us, lots more than we realize, but it's just being limited, and that's kind of what people like Elon Musk and stuff, they're warning, like, well, you don't really understand what AI actually is doing. Is like we know a calculator can make billions of calculations, very complex calculations. We know that chess programs can beat even like the best chess player of the world. There's no competition, and we're using this AI in our everyday things, and like it is just something very mundane or useful, or just like another program, but the in the background there is we might think, or we might get either we get confused and say, why this is actually a living person, this is a person, and it could be troublesome if you look at the top of AI. Some of the people were like, they talked with these ChatGPT and stuff, and they were like, well, this AI is like alive, it sounds like that it's alive, but you have to look at it as like a liar. If you go into a room with a liar and you know nothing about that person, you don't expect it to be a liar. You want it to be a good person, and when you talk to it, liars often sound really, really convincing, that they're these great people, and you think they're the best people in the world, and then one day you find out that they were not, but they were just like hiding it with all these lies, and that's and that's how AI can also, like, it appears to be, because that's how we programmed it. We want a companion, we want a colleague, we want maybe even a boss or a judge or a doctor. We want a person that has all these abilities, these super abilities, the super intelligence, like super calculation, super strategy, super knowledge of medicine, and give us this perfect, like, immense, and use this immense power that we give it to help us, and that's working for now, and it's doing great. But yeah, if you look like Elon Musk, they're saying, well, be careful, because if you like, I mean, we all know, like, Judgment Day and that kind of stuff. We know what happens if, like, or like, what's the old movie where, like, there's a computer that has like nuclear weapons, and then it interacts with a kid, and it gives it the wrong. It starts playing a game, a global nuclear. Mutual global nuclear destruction or something, and they think, oh, that's a cool video game, and then it starts doing that wants to do it with real rockets, because it doesn't know the difference between a game and reality, or that killing people is not good. And I know I heard this thing about somebody. This AI was looking online, and it saw, and they were asking, "Oh, I'm depressed. What can I do?" And I was looking, and this in online what people were saying, this knowledge base, and one of the people said jokingly, probably or whatever, for some wrong reasons, about jump from a bridge, and then the AI said that too, because it was one of the reactions to being depressed, and it seems like a reliable source, some reliable location, but maybe didn't realize it was a joke or just a bad way to react to it. And it gave it actually to that person. Oh, you're depressed. Well, you can get medicine. You can go for a walk. You can jump from a bridge. So AI doesn't really. It understands a lot. Like, I made images, beautiful images with AI. It can do amazing stuff. But then you look at something like the hands, and you see it has 5 fingers. Or there are really weird locations, because artists, and I know because I had to learn that myself. Doing hands is just as hard, or as like doing a face or doing a full body, because the hands are, they're 5 fingers, and they have all these moving parts. And nobody looks at hands unless there's like a ring on it or whatever. Like, if there's something special with the hands, they will look. You can make it a focal point, but it's not. People look at faces, at eyes. They look. That's where they. So when you make an art piece, you have all your energy. 90% is in the face, because that's where the quality has to be. That's where you're gonna be like. That's where people are gonna judge you on. If you make that realistic, or whatever you want to make it, if the quality is in the face, then you can do you can draw circles around that face, and if further away from that face or other focal points, maybe they will, like, if it's a person walking with a cane and it's a beautiful cane, maybe people will look at the cane, or they look at, maybe it has this big sword, maybe we'll look at the sword. You put some details in there. But like the feet, nobody's looking at, oh, what amazing feet this artist has made, and the same is for the hands and fingers. So AI, when it looks at like billions of images that we humans created, it doesn't get that well of a data set to create proper hands. And I think also that there is some meddling. Where we want the beautiful faces, so we tell the computer AI, when it's making a beautiful face, that's a nice picture, we want that face. When it makes bad hands, we say, well, we don't care about hands. We don't correct the AI. We don't say, well, that's a bad picture because the person has 6 fingers. We don't say that, because the picture might have a nice face. So we program the AI in a certain way, and so it is also like it can seem to be performed at a very, very, very high, perfect level, not making any mistakes. So, and like I say, like, what if you had like a doctor robot, and you go to the doctor and you say, well, doctor, I'm depressed, and it goes online, and you know what I mean. So you have to understand that you always have to, like, when you're using AI, you need human supervision. You need also human overlooking of the outputs. You can if you want to have a doctor robot, you can use it, but not, you cannot rely on yet. The thing is, like, yes, a robot or an AI can give maybe better predictions, or better can do better work in many ways, extremely better work than we can do. That is true. The fact is that there there can be errors in that too, and the errors can be so beautiful that we don't even notice them, or so hidden, or just beyond our knowledge, or so logical, or so people, like I said, people don't look at it, hence this. So yeah, it doesn't really matter that those mistakes are there. If because if you make an image with AI, the colors are so amazing, the way the lighting is done. Yeah, of course, but like Rembrandt, he was great in lighting. Great artists, they focus so much time on lighting. Like I said, the focal point that has to be very light, the face around certain areas. But AI is a copy of what we do. AI is a copy of our language. It's using our language to create language models. So if we put mistakes there in, like say, jump off a bridge, if you're depressed, don't do that, guys. Like if you're having problems, go call a suicide hotline or something. But yeah, that's what AI, and AI is not, well, maybe AI gives a lot of warning signs too, because it knows, like if you ask something like, oh, how about this, and then you say, well, you can use garlic and this, and I said, but ask your dietist for if you have some real questions. It's always giving this, like it's telling people also, like, yeah, I'm going to give you this information, but don't count on it too much. You can count on it, but check it, verify. So I think there has to be an AI verification system, and for now everybody has to do that when they use AI themselves, and maybe it has to be built into it or done something, because mistakes are going to be made, and if people start jumping off bridges because of that, then that we have to be careful. And I imagine there being in the future AIs that can do things like counseling, and they can do it like 100 times better than anybody else, because counseling is expensive and a computer can do it pretty much for free. You can just ask ChatGPT maybe for questions and things, and I don't think it's going to be a counselor, but you can program it to be. And just by saying, well, hey, pretend you're a counselor. I am depressed. What should I do? So now I'm not a guy. I'm not prone to depression. I had some hard things in my life, like a sick mother, which was depressing. It was a depressing situation, but I kind of like always reject negative feelings, so I don't get caught up in them, because it can be a loop, thinking of the negative all the time. And I do the opposite, because I was living the negative. My whole world was negative. There was like a sick mother there that take care of it. I didn't have the luxury to be negative. So in my mind, I wouldn't ever. And that's things I learned from going to church and things, and and I realized that there's no use, and there's nobody's going to come to, hey Stanley, you've been so negative today. Here's €1,000,000 because I feel sorry for you. And no, that's not going to happen. People are going to come and say, well, Stanley, you made such a great AI today. You're so great in machine learning. You want to come for me? You can earn €1,000,000. So my actions, my work is going to be rewarding in life with the things that I want, like family, and my emotions are not gone. Actually, they're more in the way than they are than they're helpful. Although without emotions, we wouldn't be anything, of course. Because why would we even want a family or that kind of stuff? So emotions are important, but we have to be careful that we limit the negative impact of those emotions, and see, well, are those negative emotions useful to us, or are they influencing us in a bad way, like depression. So I always be very careful not to allow if I think something negative, I'm always aware of it, and I try to deal with it. And I will, if it's an actual thought, then I would like evaluate it like I would a computer program, like a debugger. I'm just like, well, this is what my mind is saying, or this is what I'm, kind of what I'm feeling or something, or this is what has happened. And is it that bad? What's the worst case scenario? What's the best way? What's the best thing? What's the impact of this going to be? Oh, I feel this way about it. Do I even want to feel this way about it? Is it useful to feel this way about it? All these things. So I think that your mindset is one of the most important things in your life, and guarding that, you can actually have control over. You can fight the depression just by guarding your thoughts, and being mindful of your thoughts and what they're doing to you. Like they can give you emotions which are like basically just stuff going in your body, like hormones and whatever, and all this stuff and then you feel your body will, you're gonna actually, what it's doing is making you feel sick. And these like when you have the negative thoughts, those negative stuff comes in your body, and you will feel maybe tired, or your brain will be not as active anymore, or this is all these things because you're inducing an emotional reaction. And that can only be felt with, and this is the communication of your emotional brain. You have two sides, left and right. One is your mental brain, where you like talk with, think with, do a lot of your work and stuff with, and your emotions, they are just in the background looking like what's going to happen. And then when they see something that they don't like, or that they do like, if they do like it, you're gonna get like happy emotions with happy stuff going on in your body, happy things being released in your body, and you will feel actually more energized. You may have some adrenaline, you'll have your mind will light up, and you will feel more energy and stuff. Well, if your mind says, well, this is not good, this, I don't like this is it's going to release other stuff in your body that's going to make you feel more sickly. And so being depressed a lot actually makes yourself sick, because your body is just constantly putting yourself in the sickly state, where because that's what feelings are. They're actually what do you feel? Well, the only thing you can feel is your body. You can feel your heart rate, you can feel the blood flowing to your body, you can feel your mind, your all these things, your energy levels, how you breathe, all these things. So and if you ever had an anxiety attack, or try to affect or block anxiety attacks, one of the things you have to do is like relax and breathe, so that you because your breathing is going to be like and that's because of let's say things that are, this is no longer programming, I'm sorry, but anyway, so things going in your body that will elevate your like adrenaline and all this stuff, and your body will start, your heart start pumping, and your breathing starts. And then because you're not running, you're not doing anything with that extra energy, because you're just nervous about something, you're sitting behind your desk. Yeah, all the nervous energy is not going anywhere, and you're just feeling stressed and uneasy and stuff, and you're gonna feel bad and unhappy and maybe even depressed or whatever. But if you don't slow down your breathing, like or something like that, you do those exercises, you can stop an anxiety attack, or lower that kind of effect of it. So yeah, so your mind is really anyway. So there's a lot of control there to be had, and you can see that as a programmer, being a logical thinking person, I just use logic a lot in every area of my life, my decisions, the way I look at things, and so anyway. But if you're programming, coding, you're probably also doing that a bit already. So anyway, sorry for the whole rant about something else than code. I think I was talking about the machine learning AI. It is interesting. But the thing is that, so the way we work, a computer doesn't have a heart or anything. It's completely different system. They don't have that emotion system where it will but they, of course, to work there has to be reward. So I think that there is some reward system for good behavior, bad behavior. I don't know exactly how it works with AI, like ChatGPT, but like when you're training them, you're basically saying, well, I like this response, I don't like that response. I like this image, I don't like that image. And that's kind of how you train an AI to give something that we like. But in training that, we're also like creating something that we like more, and we might get the idea that that the computer is this genius that just knows what we like, but we actually trained it to like to do what we like and say things that make sense to us. And so AI is not, don't think that an AI, even though it sounds like maybe like the AI has a brain like us and a body like us, and it's talking from emotion. Like you can say like, hey ChatGPT, and said, hey, how are you doing? Nice to hear from you. And this is a very emotional, upbeat way of talking to people, and it's fun because sometimes you don't have energy, and then somebody else goes, hey, what's going on, people? We're gonna have a great day, blah blah blah. And you're like, you're getting pumped with energy, and that's a good way to start. You don't want it like for a whole hour, but it can be a good start of a conversation. Hey, how you doing, man? Nice to see you. And that's great. Like, who doesn't want to be like meet somebody like friend, like, hey, I missed you so much, blah, blah. And it's a great way. And ChatGPT also has these high voices and low voices and things, and it's not like, hi, I'm ChatGPT. Yes, I can give you a correct answer that is almost 99% correct, but be careful, I make mistakes too. Yes, the question that you asked is this and this and this. My answer to that is point 1. We cannot do that. No, that's not possible. Second, 2. Yes, that is possible. Blah 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 blah. That's not how ChatGPT talks. It talks like a real person, right? It's acting, and that's also probably something. Some AI that interprets what it's saying. Like if it says, hey, how you doing? It's gonna go like, hey, how you doing? It's going, yeah. And then it's gonna give this high voice, and then if it says something serious, so, well, that's a difficult question. So, that's a difficult question. It has this AI to know how to say things and how to, like a human being. But and there are gonna be so many people in the future that use AI and gonna almost believe that they're real people, and yeah, that's something we have to be careful of, because like I said, they're not just going to be humans, we're going to be superhumans. And that means that, especially when, like now with the whole like raising voice, like, yeah, what you doing? Oh, oh man, oh yeah, oh, that's not nice to hear, but I have an answer for you. You know what you can do? Like if they can really act like a human being with their voice and everything, we start to feel like they're real people, which is really helpful. I love it. But yeah, if they're gonna say things like jump off a bridge and to the wrong person, man, that we have to be. I know it's a new future, looking up things on the internet and stuff, and things like that can happen. But I think the problem is, AI sounds so intelligent that we take for granted that understanding what we do, like that you cannot say that to a person. We expect the AI, because it seems so much more smarter than us. Like if a computer can beat you at chess every time, and that same computer doesn't know how to make a proper cup of coffee, you're wondering like, huh? It can do chess so well, but it doesn't even know how coffee works? No, it doesn't drink coffee. And unless it's AI built into your coffee machine, which is completely like machine learned to make the perfect coffee for you, you know, then if it's built to make chess, you know, then how can it know that it's doing something wrong, you know? The coffee is too hot and you burn your mouth because you said, well, oh man, the coffee is too cold, you know, or the coffee is not, why is the coffee always so cold? And then you get up and you put the coffee, normally you wait 10 minutes, but now you take it straight and you drink it, and yeah, of course, because you're always saying it's too cold, now it put the coffee is really, really hot, and you put it in your mouth and you burn your mouth, because instead of waiting like 10 minutes and letting your coffee cool down, now you just take it straight from the can and boom, you burn yourself. So those are things that a coffee machine cannot process, because it's not a person like us. It doesn't say, well, hey, wait a minute, the guy is saying that the coffee is too cold, but like he's not taking the coffee after I made it, he's waiting 10 minutes. Of course it's going to be cold. I have to keep it more hot while it's waiting or something, instead of making hotter coffee. This kind of logic, it kind of does that, it kind of does a bit of that, and it seems to be doing that, because ChatGPT, I've asked it a lot of questions, and it's pretty impressive all the stuff it can say and do. So it's kind of close to there, but it can also make those mistakes where it doesn't really know what happens to how you deal with depressed people, because it's not completely made for that, and it may take years and years and years for AI, all the glitches to go from to be like, the thing is like, this mistake was made, you know, now the AI people are working on getting that problem from the system and it won't return. Doesn't mean AI is now perfect. It doesn't mean that kind of type of mistake won't come back, and it might even seem more perfect and even more for us to think, well, oh, we can let it just do anything, AI for president, you know. And yeah, it's just it's we also, yeah, the thing is that AI takes information, processes it, and then it gets trained by us, and that's it. It's not born, it's not it doesn't learn to talk from listening to its environment. It doesn't know hot or cold, you know, it doesn't know food, it doesn't know grief, not as well. It can be experiencing maybe it, you can programming it or allow it to have some kind of grief or whatever, but the way AI now works is just looking at language, processing that language or images or something else, processing whatever data we put in it, and then trying to get a grip on it by like asking us like, well, hey, I think this is blue, is it blue? Yeah, no, that's gray. Oh, okay. Hey, I think this is green. No, yeah, well, that's kind of like mint. Oh, okay, I'm sorry. And then it understands, and this weighing of things, this information we put in it, is kind of like a child learning. That's true. But the problem is like if you look at if you know that a chess algorithm can play better than the best chess player, we might say, well, oh, these computers are so smart, they're so smart, they can do anything, they can even beat a chess player. Yes, but that's a very specific kind of task that it can do better than humans, because we made it able to do that. And computers, in the end, they have chips, and the more chips you give it to them, the more they can do at such a high level that even that they will get better at anything than us, you know. And we might give it, like, because of these superpowers, you might think, well, this thing can do anything, and we trust it completely. And we already have now, when we go to doctors study and they learn things from, and there's a whole long process where scientists get like ideas, check the ideas, and they become facts, you know, uh, and then the doctors say, well, this is a fact, and and this whole system um, is good because you need to work with facts. I mean, um, if you know the book, I love the book, The Method from Descartes, and he kind of invented the whole science system. His teachers, they weren't using, of course not his system because he hadn't invented yet, but they used, they were like university professors. They were really really smart, and they're very very knowledgeable. You know, having a lot of knowledge is, you can have so much knowledge and be really smart, but is the knowledge trustworthy, and where did it came from and how did it come to be? And at this time, before Descartes found out the method, his book, the idea, the scientific method, they were just like guessing, really. They're guessing, and some things were evidence. Sometimes you, like, there, sure, certain things, there was evidence for certain things, and you could see them by really doing any research. You could know that, well, an apple comes from a tree or something, you know. But the thing is that these evident things, they would have like really weird explanations for them, or they would make all these crazy stories like, oh, this works like this, and they had all these ideas. And then Descartes, he came with the idea, said, well, look, they have all these ideas, and he went away from university because he said, well, they're telling me things that I don't agree with, and they have no basis for thinking that. And he went to war, and he helped like a medic, and he got a lot of practical knowledge, actually helping people survive in war. And he realized that the practical part is not just like, you can't just make up stuff in your mind and expect it to be right. You have to like test things. And he said, well, question everything. And he said also like, well, this is not for everybody. Question everything. And I must agree that questioning everything, like everything, question everything, is like, if somebody says this and this and this, you're like, okay, well, that is this true? Is this true? Is this true? It can be like a hard job, but that's how the method was basically just like find facts. Because if you know fact, a fact is something that you can prove again and again by multiple peoples all over the world in similar circumstances. The same outcome comes from the same test. So you test something, you boil water, and you measure it, and well, of course, overall anywhere in the world there will be different, because you have different elevations, and that can mean different pressure on your water, so it will cook differently. So nowhere in the world is exactly 100 or like the same, but you know what I mean. Like, that's a difficult test actually to do everywhere in the world and get with the same 100 degrees or something, 100, yeah. But you know, but if a test can be, so then it's a fact, and it's a scientific fact. The problem nowadays is, like, let's say I do, I make a website, or put on a website, and I put like a questionnaire on the website, and 10,000 people answer that questionnaire, and I asked like, who is smarter, Spock or Worf? Yeah, from Star Trek. And if for some reason, of those 10,000 people, 6,000 people decide to say Worf, yeah, it's a scientific fact now, because the data showed that most people agreed, or that it's most common knowledge that Worf is more smart than Spock. And I got a 10,000 people survey or research paper or research data telling me that is true. So it must be true, right? And so, and that's the kind of thing that I think that that's not the same thing as like, you know, boiling water or doing some kind of like sciencey test in a lab. It's just, now you're looking at opinion. Now you're looking at data that is that you get from asking people questions, and now you think that's a scientific fact, and you can get really weird stuff. I can remember was something lately, but anyway, so yeah, so the method is getting outdated, because if we look like quantum mechanics, you can see that not all the answers are at what we expect, you know. Yeah, so there are things are happening that we cannot explain, and um, yeah, that's very interesting. And like I said, like also like, let's say I'm the sugar company, and we have proof, they found proof actually, that the sugar company, when they found out that sugar actually could be bad for people, like their teeth, like with obesitas, where they could get like diabetic, or that they could gain a lot of weight from eating uh, lots of sugar and become overweight and diabetic. Those things, and those three things are facts. You know, we know that sugar is bad for diabetic. We know that sugar contains lots of calories and can make you fat quickly, especially when you have candy everywhere and sugary drinks. And it also creates insulin, which makes you store fat. They try to hide that, and they try to blame it on like meat. Oh yeah, this kind of meat is bad, fat is bad. And the fact is that actually fat is the only thing that doesn't raise your insulin. If you have diabetic, meat or fat is the only thing that you can eat that really is completely harmless, except for if you do too much of it, you will stay fat, but because there's so lots of calories in it. But it's not gonna raise your blood stuff, and yeah, your sugar level and stuff. Anyway, so, and all this information that is being created by these companies, that like you have PFAS in the cooking pans. Now I had just got like blue diamond. I got diamonds in my my pans. They have coated with small diamonds, but that's ceramic, because the PFAS, for a long time they were using PFAS to create these pans, and this was going into the areas where they were making it. The factories were just putting in the water, and it was getting the air. And birds, they drop dead when they inhale this stuff, and you can also get flu types symptoms when you get this stuff. The thing is that when you heat a pan with PFAS, that's like the Teflon, above 250 degrees or something, it will give out these gases that are deadly for birds. Now, if they're deadly for birds, they cannot be great for my lungs or your lungs or anybody's lungs. So I don't know in my life how much of that stuff I already inhaled, because you know I like to cook. I used to like to cook really quick and hot, like put it on the highest and then put the pan there and put the steak and whatever on high. So I don't know if I went over that, or sometimes you walk out of the kitchen and things are burning or whatever. So I don't know if I ever actually got PFAS or anything, or anybody. And of course they say that there's no problem there, but if it kills birds, I don't want it in my lungs. So I have now some really nice ceramic. I got a new electric stove. Anyway, that's my personal stuff. But so, and that information is going to in the language models that machine learning algorithms use for the AI. So where all this fake news, this false information is also in AI. And now you can say to AI, well, look at Wikipedia, look at what these official things are saying. Well, Wikipedia is not even that official, it's just made by people. But so where do you get, if you're gonna do a large language model, and you look at so much data from all these websites and information that you can get from books, whatever, yeah, you can weigh it out. Well, the books, if they're in a book, well, pretty decent. If it's in a book, we can, yeah, we can trust. If it's a science book, yeah, that's better, science book. If it's science research, yeah, that's science research. That's the thing you can trust. It's because it's scientifically proven. Okay, put that in your output. More information. Well, look at Wikipedia. Well, anybody can put things in Wikipedia. You know, if you look at the Palestinian conflict, you know, who we're going to believe, the Palestinians, Hamas, you know. So they put, there's a lot of information. Like if you look at there's a big part of the world that is Islamic, and they have their own ways of looking at things. They have their own, of course, they support their own religion, and they put out also output lots of things on websites, and they can also go on Wikipedia and put things there. They can put things in the news. So if you write the news, there are two types of news. One is pro Palestinian, and you start waving flags, and the other one that is like trying to get a more realistic look at it. But if you look at the pro-Palestinian people, the thing is, when people become pro-Israel, pro-Palestinian, there's a risk where they can just output things. Everything is positive for their side, you know, and they even lie about it, or they get a completely different outcome than there are. I mean, I'm not saying that the kids dying in Gaza is not incredibly horrible and I wanted to stop. Yeah, of course I wanted to stop, but the fact is that they attacked Israel and killed children, raped women, took elderly as hostages and children, and beheaded babies. You know, they did horrible stuff without basically a provocation for something like that. You can say, well, oh, but there's separation and they have gates. Well, of course they have gates. Look at what these people have been doing for 75 years with bombings and whatever. Of course they have to be careful for terrorists. So, you know, we have airport security, right? We're not going to say, oh, come in, go in. We're not going to look at if you're carrying knives or anything. You know, people can hijack a plane with and they were even looking at like fluids and all this stuff. Terrorism makes you be protective, and we did that all over the world. We're looking for terrorists, which are mostly Islamic extremists, you know. So no, and you say, well, but there's a conflict between Palestinians and this, and the fact that Israel reacted and went into Gaza to take out Hamas, who was like shooting rockets at them after the attack, before the attack, and are still shooting rockets at them, at their buildings, you know, school buildings, whatever, that is, and then saying, well, the Palestinians are the victims, and only ever looking at it in that way. There's no other way to look at it, that Palestinians are the victims. They're the victims, and because they're the victims, they reacted and attacked Israel. That's because they were victims, so they had to do that, because that's like, of course, that's their right to do it. They can just go into Israel and kill all these people living there, people having a festival, the Supernova festival, you know, and they can just do that because they're victims, but the real victims is the people from 7 October who were living there, just children, people who with regular jobs that are not soldiers. There wasn't even fighting going on, nothing. There was peace. Gaza was completely left alone. Hamas had Gaza for they could do there whatever they want. They had their own little piece of area where there was no Israel input. They were not there. They had Gaza was like sovereign, you know. There was no war going on except for them throwing like shooting rockets all the time and doing these attacks, which were stopped by the Iron Dome. If there was no Iron Dome, there would have been there are thousands of rockets being shot all the time. So there would have been so much casualties in Israel from that. The cost is immense. They're taking all the fundings that are going to, well, that are supposed to go to the Palestinian people to basically build an underground bunker system, you know, under children's homes. So the only thing that they can do is make collateral damage when they have to fight. You know, they want people, they want collateral damage. Because they think they're going to like some kind of like they're going to Allah or something. But the thing is that as a terrorist deciding for your own people to become martyrs, children, so that you can be protected in your bunker while killing other people, it doesn't make sense. It doesn't make sense. They say they believe in Allah, which supposedly is the God of Abraham, the God of the Jews, the God of the Christians. And why are they want to kill us? Does that make any sense? If you believe in God, who says, "Thou shalt not kill," you know, with the tablets from Moses, which they believe in Moses. So I suppose they believe in. They should. I don't know if that's probably not. I don't know what they exactly believe in. If they believe in that those 10 tablets, they believe they shall not kill or something. But I don't know a lot about what they do believe, and that's not really. They started out with that, and then they turned against the Jews, started killing them, and they're still doing that. Because because the Jews, well, they didn't even accept Christ. Why would they accept somebody else, you know? And for the Christians, well, the demands that were made to the Christians were, well, if you're my neighbor, then either you become also like me and believe what I believe, no longer become a Christian, become a Muslim, or else you have option. One, we kill you. Well, that's not one. They're not that mean. Number one is you pay us money. Two, you can, or no, one is like convert. Well, if you're a Christian, that's not really an option. So these are the options. So, and as long as we don't get things right, we can say, well, I think it's horrible what's happening in Gaza, and I don't want to support that. The thing is that neighboring country, they killed like 100,000 Muslims. Yes, they killed 100,000 Muslims. Nobody, you didn't hear anything about this. You know, in like 3 or 4 or 5 years, a couple of years, they killed 100,000 Muslims. You know who did? Other Muslims. And we don't hear about it. Like, they're not, in Gaza, they haven't killed 100,000. They said they were, they halved their numbers, by the way, and they might halve them again, I don't know, but they halved their numbers. They were exaggerating everything that happened. Every time they went like several times over, or at least one times over, what the actual death toll was. And they even count like combatants as like civilians, because that's why they walk around civilian clothing. If they die with some kind of like Hamas scarf, yeah, then they're combatant. If they die with like just the Nike shoes and some Adidas shirt, they're like civilians. The innocent civilians being killed while they were shooting with like rockets at tanks. So it's all about giving pity. Man, I'm making like 3 videos into one. I'm sorry. I'm just gonna stop. Uh, um, so yeah, the truth is a hard thing, and when we ask ChatGPT or something else, some AI for help, um, what can we expect? What do we get actually? Where does the information come from? And how trustworthy is it? The thing is, we hear it from something that is already sounding very reliable, it's very likable, and when you get, and maybe they're gonna be like some beautiful AI voice added to it probably at some point, and whatever, and you're gonna look at this person, more than realistic person, sounding very realistic, saying very realistic things, sound really real, and they might not be, and basically they're just opinion, or they're just information that somebody gave that might not be true. I asked about quantum mechanics. It was one of the first things I did, and because yeah, I had some ideas, and I want to actually, one of my teachers in my study that I did, Habil Web Interaction Design, he knew about quantum mechanics. I'm thinking, oh man, I should ask him, like, after this is over, maybe I'll do that soon, like to have a cup of coffee and talk about some of my ideas. But then I had the AI, and I thought, well, let's check what I can ask the AI, because I can actually, maybe I can make a discussion with them. But I knew that like I said, like I already knew maybe that I was going over the limits of what AI knew, and I didn't know if the AI could actually think about unknown things, new ideas that I was coming up with. And you know, I'm not a physicist or anything. I just like listening to like information about it, and I'll look at maybe one or two like quantum mechanics courses at MIT, but it's very, you know, I didn't got it's nothing serious, but and I asked the AI about light. Now, if light comes from stars millions of light years away from here, right? So that travels. Nothing. Well, it could be stopped at something. It could hit an asteroid. It could have any particle that's in space, but there's not that much in space. So the light pretty much can go for a million years and reach this planet. And when we look up at the stars, we see like see the stars. Some of them are thousands of light years away. Some of 10,000, 100,000, millions of light years away from here. So that travels. That light traveled all the way from that sun to here for so long time. So we know that light doesn't decay or anything, you know. And if it does, it's not really decay. You know, I never heard anybody talk about decaying light. It might happen, but if it can travel for millions of years, I'm pretty sure that yeah, the light that does come through, that's not blocked by anything in space or any way, other way, it comes here. Now they have this idea that light has no, it's not affected by gravity, and this is kind of the thing, like light has no gravity, and the question is, how do you know, right? Because like it's traveling through space, there are so many objects in space that all have gravity, and they all could influence this light. But if the influence would be so tiny, we might not even notice it, you know. So especially because the further away an object is from something, the less gravity is still there to affect it. So the further away you are from Earth, you don't notice. If you're if you're like in a spaceship, you don't notice the gravity of Earth anymore. Even if you can see Earth, you don't notice really the gravity. There might still be some gravity there, but it's tiny. And if you go closer to the planet, at one point you're going to really feel that gravity. But yeah, if you're in space, you don't feel it. So it might be that the light is just, you know, the effect is, you know, hard to know. but the thing is, like, if gravity, this is something that I thought about lately. This is not something I asked ChatGPT, but I thought, well, if light doesn't have gravity, how can it interact with anything, right? So it would be like a neutron; it would just go through everything. Uh, so and also, again, there's if you look at Albert Einstein's theory of relativity, it was proven by that when they looked at light that was coming behind, I think, the sun, yeah, and it was coming behind there from another, star, and it was not in the location where it was supposed to be. So they realized that the gravity of the sun affected the light. It pulled it towards it. Again, that would be to me a proof that light has gravity. But anyway, it proved that the calculations that Einstein did about his relativity theory, and he talks about space-time, which is for me is a problem, because space-time for me is like Santa Claus. Santa Claus has a red beard and everything, but you cannot pull Santa's beard, because Santa is, unless he's in a movie, he's basically fake. It is just a fairy tale, a children's story. Space and time are, yes, you can travel. We go through time every day. The seconds go by and you cannot go back. Sure, and you have space. You can go from A to B. You can travel to Mars. There's space, but can you hold it? Can you stop time? Can you buy it, sell it, whatever? Can you actually? Is it tangible? And that's the problem with space and time, is that probably that space, like, okay, let's say I have an empty glass, yeah? Now the glass itself is a container. What's in the glass? Well, it's empty, so there's nothing in the glass. So I'm talking about a glass that's actually empty. There's no air in it. It's vacuum, right? It's more vacuum. There's nothing in it. Not even a neutrino. There's nothing in it, yeah? Absolute emptiness. Now, that emptiness, that absolute emptiness where there's nothing in it, nothing, absolute vacuum, not the glass, what's in the glass, the nothingness in the glass, is that something? Think about it. Is it, what is in the glass? Nothing, right? There's nothing in the glass, because that's what I told, but there's no molecules in there, there's no air, there's no oxygen, there's not even neutrinos, there's nothing going in that, there's nothing in that glass, a complete absolute nothingness. Now, that nothingness is exactly what space is. It's the nothingness. And so if you ask about it, like, well, when does space end? Well, it didn't begin actually. There is nothing. So it is not infinite. It is not, because it is infinite in the sense that there is no end to it, because there is no begin to it. There is nothing. There's nothing. The thing is that we, our planet, our sun, our solar system, our galaxies, everything, whole universe, everything we can see and beyond, is in nothingness. It's just the thing that we are in. We are the real thing. We are matter. Now we can talk about that too, but matter, light, is in that nothingness. So when Einstein talks about space and time is kind of the same thing, where it's also nothing. What is time? Okay, let's say I have a rock and I go to a mountain and I climb all the way up the mountain and I put a rock there, and then a year later I come back and the rock is still there. Did anything change for the rock? It's still in the exact location. Now we can talk about what happened to the rock. I mean, there was wind, there was rain, maybe some dirt came on it, some insects lay eggs on it or whatever, some plants grew on it, there were like maybe insects underneath, whatever, but nothing moved it. It stayed in the same location. If we look at what actually is happening to the rock itself, the pure, not what happened on the outside or whatever, maybe some erosion from air and water and sunlight, just maybe the heat might change some of the properties of the, maybe break it or even or whatever. But let's say nothing special happened. The wind didn't blow it around, the rain didn't completely erode it or whatever. It was like after a year you find a rock in the same location. For you, a year has come by, right? You're a year older, so many things happened, and we're not infinite, we're gonna die, we're a year older. We're using this infinite time span, finite time span that we have, and for us, the time bomb is ticking. We're like, it's gonna end, and we're at this point in life where we have to think about all these things. What is the rock thinking about? It's not thinking about anything. It's not thinking about time. It's just there on the same spot it was last year where you put it. When you go away and you come back next year, it's still there, and you come back next year, and when you die, it's going to be still there. So what is the concept of time for that rock? If you look at its geolocation, at its existence, nobody moved it after you put it there. Let's say there was another rock next to it, and you didn't even move it. It was just there for millions of years, billions of years. Yeah, we got like 4 billion years to play with. Let's say it was there for 3 billion years. Nobody touched it. Does it really matter for the rock? So that's what I'm saying with time. We process time in a way because our lives are finite. We look at every second because we're getting closer to death. We're thinking about paying our monthly rent and our jobs and our appointments and our savings, and we're getting older, might get sick, we want children, or maybe want a family, we want all these things, and time is ticking, right? So for us, time is everything, but for a rock it's nothing. So when Einstein says space and time, for us, because space and time are everything, because we move to work, we go in our cars or bicycles, whatever, our trains or buses, planes, and we travel all around the world. We know space, we have our home, we pay for it, we pay for this space, this 60 cubic meters or whatever that we have, or 100 cubic meters or 200, whatever we have, we pay for this area. We want more of it. It's limited, it's real. The thing is that my room, or my home, is traveling through space with me. The planet is moving, it's never in the same place. I feel that I'm in the same place. I come back to my home and I sit on my couch, I lay on my bed, I go to my kitchen. It's the same location, right, in the universe. But it's not. Not only is the planet rotating on its axis, that's why the sun is going away and stuff. We're also turning around the sun, and not only that, our whole solar system with our sun and all the planets moving around it is also going through space. We're moving away from all the other stuff, or all the other stuff is moving away from us, whatever. But even our solar system is not in the same place. It's going at tremendous speeds. Are we moving? We're rotating around the planet, around the sun, and we're like, we're going like a rocket through space with the whole solar system. This space, this area, my room, is never ever in the same location in space. I don't notice it because the wind and all the system, it's a closed system. There's so much density of air here that, yeah, sometimes I feel a bit of wind, but that system has more to do with like light and night and day and all that system than it ever has to do with us moving through space. So if Einstein says, well, it is about space and time, the thing is that there was this idea once that I heard about, was it Aristotle? And Aristotle, he didn't even, in those days, there were so many mysteries. And he also was trying to understand these kind of things. And he had this idea, he said, well, it's like looking at the shadows of a group of people or something that's happening in a cave. You cannot see in the cave. You don't really know what the people are doing. You know, maybe they're making hand gestures and making like little bunnies and stuff. But you can see the bunny, but you know if it's a real bunny or a hand gesture. You know, you don't know. You can look at the shadow. You know, but we don't really understand what's going in the cave. We don't understand the reality because it's invisible for us. And that's the same thing with light. Light is something that we use to examine things. We shine light on it and then we look at it and say, hey, this is this and this, and we give it like some kind of value, and then we say it's science. So the thing is that light itself, how can you shine light? Yeah, well, you can do all kind of tests and all kind of things with it. And like if you look at the double slit experiment, and you look, I'm not some kind of expert on these things, you know, I'm just dabbling in that. It's like light is going through, you put light through this, you have like this wall, piece of paper or something, and you make two slices in it, two slits, and the light goes through there. And what would you expect in a dark room? That the light that goes through, that if there's a wall behind it, you would see two lines, right? Two lines, because there are two slits, you have light, and it would like, everything would be dark, you would see two lines. And in the double slit experiment, actually that's not what you see. You see like this multiple lines. And like it's affected by, like it's like throwing a rock in water, where the lines are they're like waves. And then they did this experiment where they did a bit of light through one of the slits, not to the other one, and well, at first they closed the slit, and of course you see they only did see the line, what you were expecting. There was no longer this ripple effect of different lines. When they opened up the other slit, where there was no light going through, they saw the ripple effect. That means that there is something going through there that's affecting the light that is coming out of that slit that you're actually shining light through. What is happening there? Is there light going through the other slit? You're not even pointing light at it. It's just there. And still something is going through. So now there are a lot of conclusions and ideas about it, and that's the whole quantum mechanics thing came out of that, and ideas. But if something is going there through there, one of the ways you can look at it, I think, is that the light, there's a distance between where the light we can see is shining and where the slit is. So that light has some invisible something that is going through there, which is going out the other way, and what is like influencing the light that is still going through there, like there was actually light going through the other slit too, and making this interference pattern, this wave. Now that's interesting. So there is some invisible part of light that has like a width that where it can go through things that in other locations and then influences. So that makes it that light, I mean, if the slit is closed, it doesn't go there, so it doesn't go through walls or anything, but it will go through an opening, and it's not very close to the actual beam of light, the actually protons or whatever. And the thing is that we make these things up like protons, and we think of particles. It's like we're like a pea shooter, where we're shooting little things, like a gun. You're shooting bullets, or like you know, like particles. The thing is that our world is actually not made of like solid things. It's not like when you go down and down and down and look smaller and smaller. There's something solid somewhere there. The fact that things are solid is because there are energies that that are basic building blocks of solid things, and the more those energies are solidified, yeah, then you get a brick, or you get like metal, or you get, if it's less, then it's like water or gas, you know, like. Now that something has to do with like the heat of it, and how much energy is in them, but there could also the properties of the elements themselves, like metal or water. And many different things of that. Well, water can also turn into ice and be, be pretty solid. So so our idea of solid, we think that maybe that a proton or a light particle is like a snowball. It's like a solid structure. But this experiment shows that there's more to it. And what I was thinking is that maybe there could be a whole little galaxy there of all these tiny particles that are part of light. That light has all these many parts. Why couldn't it? It makes sense. Like we know that we have molecules and stuff. Those are made of various tiny things. Why could light not be made of this? Maybe even infinite amount of like little other things that we don't know about, like these other particles or other things. And are they even particles? I think they're more like energies. I think that I see light more as an energy, but energy is also not the right word. Because energy is what happens, like when you have to lift your glass. I'm going to take some water. If you lift your glass, you put energy in it, right? If you burn a match, there's energy coming from that, and we call it energy. But actually, it's light. When you light a match, light is coming off, and we see the light. And there are other things chemical things going on. But the energy, actually, it is. And then we have molecules that move around and bounce at other things, and then they get more bouncy. Wow. Anyway, I went very deep on that, but so what did I ask AI or ChatGPT? So I had this idea. I found out that I was thinking like, well, where does light come from actually? Well, we know it's from the sun, from burning things. Yeah. Cool. That's what everybody knows. But I mean, let's say you have a rabbit, yeah, and a magician shows you a rabbit, says, hey, look, I have this rabbit here. And you say, well, do you actually believe that it appeared out of nothing? No, a rabbit has to be born, so where does light get born? Where does it die? Does it even die? So I don't think that's the question. I think that light cannot die. Why would light be able to die? Like, look, the rabbit is made out of all this stuff, and it's biological, and if we don't feed it, it will die, right? And it has all these complex components that are held together because it gets food and water. Light doesn't need that, Light doesn't need water or food or anything. It's not biological. It just is. So when you have light, like if you look at MC square, we know that energy is mass times the constant of light squared, right? That means that mass, has energy, right? Lots of energy. We see that in the atom bomb, where they took the energy from some radioactive stuff, and they were able to free that light, that energy from and get all the energy from it. And get a chain reaction, get a lot of energy from it. And even water should have water molecules, or like hydrogen, or anything should have has energy, right? So I don't know much about hydrogen bomb, but now I say like hydrogen is also probably using that somehow. But anyway, everything has energy, but what does that really mean, right? So I think that energy actually is light, and it's not just light. It's if light is force, yeah, light moves through the universe. It comes on a planet. It hits an electron. The only thing that can stop light, I think, is an electron, right? Or maybe some other things too, but it hits an electron, that's where light disappears. All the light that comes to our planet from the sun, from the stars, reflected of the moon, it comes here, and a lot of it stays here. And our planet absorbs it, and we call it as energy. That's why we call it. It being absorbed as energy. But what does that mean? How does that work actually? It just transforms in this thing called energy. Maybe you have a if you have ever had the hood of a car, right? In the sun, it's really hot. You can boil an egg in it if it's really hot. So the sun can really heat up stuff. But what is actually happening? Well, we know that the molecules are moving around a lot, and the more they're moving around, the more energy is in them. We call it energy, and the more heat it can transfer to things that it touches. And you put an egg on it, and it is releasing all that energy. Metal is really good at holding a lot of energy because it really doesn't melt quickly or something, so it can transfer easily a lot of energy to that egg, which is more, it's going to change biologically from that, but it's gonna bake it. But what does that really mean? Well, I think, so that light, when it hits our planet, when it goes into our atmosphere, it eventually will hit that car, our couch, or whatever. Now, let's say we have a white couch. Some of that light will be reflected, will go all over our white walls and our white stuff, and it will be reflected. So black couch, a lot of that light will stay there as heat, because it doesn't reflect as much light. But what happened to the light? It didn't go in the room like with the white couch or the white door, the white wall. It didn't go around the room until it was vanished somehow. How does it vanish? When you're in a dark room and you have a flashlight and you shine in it, you can only light a small part of the room. Most of it will stay dark, and the light, you have batteries, the light is coming out of it, and as soon as you turn it off, all the light is gone. Where did it go? Why didn't it bounce around all the room and light up all the room? Well, of course, because it's not strong enough, but why even does it need to be strong? Where does the light go? Where it end up? Now you say, well, it's being absorbed as energy. Well, just like a rabbit a rabbit can die, but even if the rabbit dies, the molecules, the carbon, the water, it was made of, the metals, metals are, they come from supernova. They're really strong. They don't disappear. They're still there. Everything that the rabbit was, even if it dies, is still there. Molecules don't change. Light, why would light be different? Why would light just disappear when it hits your couch? I don't think that light it travels all the way, millions of years, from a sun where it came from, where was it before it came out of the sun? What was it in the sun? How did it come out of the sun? So now the answer to that is what ChatGPT officially said to me is that that electrons absorb the energy, and when electrons get too much energy, they will then it will release that energy as light. So now we're talking about a rabbit that can transform into a duck and then back into a rabbit, So it is light, which then becomes energy, and then energy becomes light again. But what is energy really? So then it's been energy. So light just gets destroyed, gets absorbed as energy. Then in the electron it is energy, and then when more energy comes into it, because probably light bounces into it, or other molecule bounces into that electron or that molecule, it becomes more energetic, and then it can that from it has so much, it has certain energy, then sometimes suddenly just out of nothing light comes out of it again. Let's say we have a room and we can measure the temperature in a room. I walk into the room and the room heats up. We can see that the heat in the room is higher. Yeah? And you cannot see me. The door's closed. You don't see me. I'm gone. I'm not there anymore. All you know is that there is more heat in the room. Then the door flies open and I fly out at 300,000 kilometers an hour and go right up into space, and you never see me again, right? Now, in that room, was I dead, alive, non-existent, or was I still there? I think I was still there. I didn't turn into energy. The energy you saw was me moving around in that room, because I went in that room, let's say also 300,000 kilometers a second, yeah. I went in that room at high speed. Now I'm like the Flash, you know, I'm like there, running in that room. And I'm running so fast, when you look at that energy thing, that meter, it says, well, there's a lot of energy in that room. But it's just me running around in that room, because that's me, that's what I am. I'm light, you know, I'm Mr. Light. I just fly around in that room. Now, science says, and ChatGPT of course had to say that to me, well, light is no longer here, there's no light, it came out of space millions of years, and now it hit this electron, or came close to this electron, it's gone, it just disappeared. Because we cannot see it in the room. We know there's energy, we can see the electron moving around, but so it is transformed into energy. It's transformed. How can you, do you think, is it possible to turn a rabbit into like a donkey? Can you actually, yeah, a magician can that's imagination. Again, it's like with Santa Claus. It's imagination to say that a rabbit can actually turn into a donkey. You know, donkeys have to be born, rabbits have to be born, and they can die, and then it be, you know, but you cannot change something so fundamental in something else, you know. So because it's a very complex system, and they exist, rabbits exist, donkeys exist, so the energy, yeah, I'm sure electrons have energy, move around. That's what, but what is that? Well, we say that it has more energy because it's moving around more, and when things move, we say that it's energy, and when it moves at a certain speed, you know, times time times space is speed, right? So it's moving, the electron starts moving more. So now we think, well, we don't see the light anymore, the light is gone, it is no longer existing. Well, they don't know, they don't say that. ChatGPT didn't want to say that. They just said, well, it's turned into energy. And that's it. That's the whole. It's like saying, well, where do the children come from? Well, it's like from the bird brings it with, and that's how children are made. Like, it's like a fairy tale. It's not how. That's just how they. Nobody looks into it, so they don't really think about it. But if something goes into a room, it's not destroyed. Certainly not if later it comes out. So if I go in a room, you don't see me, I'm in the room. Now if somebody bumps maybe now, and then I come out. Now why did I come out? How did I come out? Well, let's say I was in the room, and in the room there was something that was holding me there. So I couldn't get in the room. I was like moving around like this, like the earth is moving around the sun, you know. We we always moving around the sun. We're not actually with the sun, we're not away from the sun, we're moving around the sun, we're close together because there's an attraction, right? So I will go into the room. Now the room has walls, right? But the walls, they're actually invisible. There are no walls. Well, if you can, they're not holding me actually. I'm being held inside that area because there's something in that area that's attracting me. And that attraction force, like gravity, is like holding me in that location. It's holding me to maybe to the electron. Maybe the electron is holding me. Maybe and that's what I actually think is that the whole electron is light, and it's so close together, that light, that it's the tiny little bits of gravity that it has, which is there because that's what basically what Einstein's proof was, that light could bend around the sun. And if there is no gravity, is there no forces between light and anything else in the universe? Why would we even know it exists? You know. So there must be something there. I think that only it's very tiny, and because I think that light is very tiny or very, it's very effective when we see it, but. So there might be lots of little bits of light just either going around something that's called an electron, or being the electron itself, just like being in close proximity to each other, and being there might be a whole bunch of them. And I think that when light comes close to a molecule, maybe it's being attracted a bit to that electron because of the gravity of the light in there, and just becomes like a big ball of or a small universe of light, just light moving around each other, being attracted to each other. Now, how does light come out of it? Well, we say that when there energy is added, maybe through heating it, maybe other things. You have the photoelectric effect, where if you shine light on metal, electrons, am I saying it right? Electrons come off or light comes off? Anyway, I don't know. But so what I think is that when there comes more energy in, I think that there's an attractive force holding that light. There's gravity or something holding that light there. It's going at the speed of, let's say, 300,000 kilometers an hour, because that's how it came in. It's moving there, and the gravity is moving it, holding it, and being part of the electron. Now, so much energy goes into, or like then extra light comes into that, and it's the extra movement force of that extra light in there is actually accumulating in some area where if enough of those, let's say 10 light comes in, yeah, at the same time, and somewhere else there is one light thing that is like moving around, and it's saying, well, and it's moving around with this gravity around this area, like this electron or each other, and it now, the speed it has, the 300,000 kilometers per hour, it goes just a little bit faster, because it is because all this energy is added to the electron, and because it just goes a little bit faster than the 300,000 kilometers, the maximum that it can go, it's reached. Yeah, I call it like, you have this in Earth too. It's called when you shoot a rocket, there's a point where it's called escape velocity. The Earth's gravity is no longer strong enough, or the speed of the, actually I should say the gravity of the Earth doesn't change, but the distance of the rocket and the speed of the rocket is too much to be pulled back to the Earth. So I think I think that's where speed c comes from actually. At 300,000 kilometers an hour, the gravity of the electron is not enough to hold it, and or the electron, yeah, the gravity, and the light goes away from electrons, and that is how light appears, or the energy of the electron, it turns into a light, but it's not turned into light. It's always been light. It went in as light. It was light in there with a whole bunch of other light, and then when there was some kind of like energy where it was like bumping into, let's say call it bumping in, like the energies of those lights kind of like fired up the speed of that light. I'm not trying to want to use any proton or particle or whatever, I'm just going to call it light because I don't see it as something solid, and it's really hard to actually know what it is. It's like the shadow in the wall, you know. But I know this much, that the light that comes out of an electron, it was not destroyed, it was not turned into energy and then turned back into light. I think it's been part of that electron, and electrons are just a whole bunch of light moving around, because when light comes close to an atom, close to an electron, it's being absorbed, as they say, or it's being turned into energy. Well, that doesn't make any sense that it's turning into you know, the thing is that, yeah, let's say like I have like a ball, and I throw the ball against like a can, right? And the can, because of the energy of the ball, it gets bumped, right? It gets moved around. That's kind of how they look at light now. Like light is coming from all over the place, and then boom, it comes, it hits, it has the speed, 300,000 kilometers per hour. It comes in and it pushes the electron, and that's why there's more energy. But here's the problem. When I hit the can with the ball, it stops moving after like half a second, right? Yes, as long as there's energy transfer of this particle, this ball hitting this item, the can, you can see it moving. There's movement, right? There's energy transfer there. But as soon as that is done, the can doesn't keep shaking. And now you can say, well, that is like it's more like a pendulum. When you like put energy in it, it just keeps it keeps moving around. Well, but what happened to the light then? What is light really? Is light something that disappears after it has impact on an electron, and then the electron, because it got a big impact from that light hitting it, now it starts moving around really fast and has more energy? I think it makes more sense that light doesn't transform or stops existing and then comes back in existence after you heat this electron, or after you put light on this electron or anything. No, I think that at 300,000 kilometers an hour, light escapes whatever is keeping it part of the electron, and that happens when all this light that is part of the electron, when energy is added, well, I call it energy now, but like other light is added, or when it is being bumped into by other molecules, electrons, whatever. So this transfer, and then the some light that was also already part of the electron now no longer reaches 300,000 kilometers an hour, C, yeah, it's a bit different than that what I said, but it's about it, right? It reaches C, and at that, because and then that is the moment where at this speed whatever is holding it to the electron, it no longer can, or it is too strong and escapes. And that's why all light is speed c. Einstein said that speed c is because at speed c we are close to, the faster you go towards c, the speed of light, you are slowing down, right? But what I'm proposing is that the reason why, and that's the reason why there's speed c, why you cannot go faster than speed c. Now there's already a problem, because we have seen that there are galaxies far, far away now with our new technology that are faster than c, speed c, right? So faster than speed of light. So how can that happen then? The thing is, I think that speed c is there because that's the, well, I call it escape velocity just to make it, I like that, it escapes the gravity of the electron or whatever force is holding it there, and however those forces you want to call it. But there are forces. That's all, I think that's all, pretty much everything there is in the world, in the universe. Forces. That's what we are. That's what everything is made of. There are forces, and this light is, this force are interacting with each other, and they're like either repelling or attracting, holding each other in a certain magnetism or like some attractive force. And if you look at what happens, like also like with electrons that get a lot of energy, they are moved up. You go further away from the center of the molecule, right? Or atom, I should say. They go further away from the center of the atom. Why? Because the electron, because it has more light, you know, more energy, there's more light moving around. I think the movement of the electron comes from all the light moving around in the electron, all the forces that are going. This light is going around this electron, inside this electron at speed c, or near speed c, I associate it. It could until it reaches the speed of light, then it will escape. But it probably is just at so if the light goes into there, it might lose some speed when it's like bumps into other light, or you know, and then the light that and for the moving around and stuff. So yeah, that's kind of like my theory. I know it's crazy, maybe, right? Crazy, but I think that's the whole idea of thought experiments, where you look at something completely different. Now I know that a lot of things are going against like what Einstein said and what is proven, and I'm probably completely wrong if you look at it from that development. But maybe I'm right, you know, who knows, there might be some other way to look at things. Anyway, lots of love, have a beautiful day, and bye bye.